All right, looks like we are live. Welcome to Standing For Truth. I am your host, Donny, and this is my co-host, Matt, or as many people may know him as Matt Man in the house. Tonight, we are educating evolutionists. Specifically, tonight, we are refuting Gutsick Gibbon. Class is in session, everybody. Matt, what do you think? The Gibbon that's sick to her stomach. She's going to be sick for weeks after this dismantling.
Yeah, no doubt. I mean, I don't know if there's a thinking cap big enough, but we'll try, my friend. We'll try.
Well, we were chatting before. We're going to make this into a series, everybody, because we have endless content, dozens and dozens and dozens of technical papers that we want to get through. So tonight we'll focus on this specific video. And then, as we move along in this series, we'll get to other videos as well. So it's good to see everybody. We got a lot to get through, so we're kind of just going to get right into it. But I'll give a minute of announcements, guys. Tomorrow night, we're back to continue the Evolution Debate Challenge, the Standing For Truth Ministries 2022 Evolution Debate Challenge. This has been a ton of fun. I've added a section on the website. So if you have not yet checked out the website, we've got endless content on there, videos, articles, books. We've got something for you. We've got something addressing, nearly all challenges, objections, arguments, and so on and so forth. So we got a new section on there that you can catch up on all of the debates that we've had. Tomorrow we've got Tom Jump versus Dr. Dino. This one is going to be huge. This one is going to be a ton of fun. We've had a great series of debates so far in this challenge. Hard to pick which one has been my favorite. I would say the one last week between Call Me Emo and Kent. That one was awesome. That was a very sophisticated debate. The one with Wade the Wizard, of course, that one was a ton of fun as well. We should be expecting a round two pretty soon, probably in April. And of course, the big rematch, Mark Drysdale and Ken Hovind. That one is getting a ton of feedback. But that being said, guys, just if you're not subscribed, but you love debates, videos, interviews, discussions, and more, just please make sure to hit that subscribe button and also share around this content, because the truth is important and critical thinking is important as well. So Matt, any words of introduction or anything from you, brother, before we get right into the fun?
No, if people know who you are, I'm sure they know who I am. It doesn't matter anyway, because it's just the material that matters. So I could care less.
Amen. Amen. And we got a lot of material. So what I am going to do then, if anybody in the chat, if you guys can give me an okay on the audio video, and I'll share screen. I'll make sure that I am sharing the audio, and we'll go through a couple minutes and then we'll pause it. And Matt and I will give our thoughts. If there's any questions as well, we like this to be interactive, then feel free to tag me or Matt. We'll do our best to see the comments, to see the questions, and we'll do our best to answer them as well. So there's going to be a lot of visuals here as well, guys. So stay tuned. This is going to be a lot of fun. So here we go. I want to make sure there's not going to be an echo. So I'm going to mute myself as we do this. And 3, 2, 1.
Erika, you run a YouTube channel that is called what?
It is called Gutsick Gibbon.
I need more. I need an explanation. What is Gutsick
Gibbon? I get asked this question about as often as you would think. And unfortunately, no one is ever satisfied with the answer because it's not that funny. But I do cartoons and animations in a lot of my videos. And I had drawn this sickly looking little gibbon, right, around the time that I decided I was going to get in fights with people on the debate evolution subreddit. So I titled my account there Gutsick Gibbon because it's a gibbon and it's sick to its guts, I guess. It sounded really good in my head, but I was like, it's a Reddit account. It's not going to be forever, right?
Well, I have a confession to make. I hadn't been introduced to you until we met at the Faithless Forum event. And I saw you on a panel and I was like, not only are you very knowledgeable on the subject that we're about to speak about, but you have an unbridled enthusiasm, like a contagious enthusiasm. And I take that as a compliment, right?
I certainly do. It's hard not to be. It's so mind-bogglingly incredible.
Okay, now hang on. I got to interrupt you. Your area of expertise, your focus is what?
I am, by training, technically a primatologist, and looking to further that with my current PhD program in biological anthropology, so specifically the study of human evolution. Think the folks who go out and find hominins like Lucy or Homo erectus or Neanderthals, things like that. But my classical training that is completed as of right now is living primates. So I love human evolution, and I love the evolution of our entire order.
You know, I'm not a monkey. I don't know what you're talking about. I'm a created being. I mean, there are humans and there are animals.
Of course, very different.
Yeah.
Yes, very different. Not
all right, someone comes to you and they say, my grandfather wasn't a monkey, I'm not a chimpanzee. You know, they come out with the tired, hackneyed arguments against evolution or shared ancestry with our primate ancestors, you know. Am I still a monkey? You know, am I a monkey?
You are indeed. Yes, it's incredible to really go through the entire chain. So I'll be briefer than I've been in the past. Most people who are evangelicals will generally accept that humans are mammals, and then they'll be like, but we're not animals, right? Because it's very hard to deny being a mammal. It's like, you know, we are covered in hair. Females of our species, of our group, produce milk. We're endothermic. We've got these dental squamosal joints, although they don't tend to bring that one up. It's a less popular diagnostic trait. But they tend to draw the line at primates. And I've never understood that, because I think that there is, as Darwin said, you know, beauty and grandeur in this view of life. But you are definitively and objectively, not only are you a primate, but you are also a haplorine primate. You are a catarrhine primate, right? You are a hominoid. You're a hominid. And you're a member of the genus Homo, and your species is Homo sapiens. All of the traits that categorize each of those groups, you have now. And whether or not you include humans in the categorization of life, those categories don't change. So there has been an accusation from some evangelicals that the evolutionists are trying to force humans into this category. The taxonomy that we work with today was invented, if you will, conceived by Carl Linnaeus, this guy who lived a long time ago, right? And he was a creationist.
All right, so we've got a lot to touch on there. Unfortunately, we're going to have to spend some time on what we call the non-discriminatory lines of evidence, or the lines of evidence that are really just agnostic to the debate: classification systematics, nested hierarchies, the fact that we can classify various creatures and animals, and then to the meat of this, the genetics, the best way to determine ancestry, right, Matt? It's not, you know, a classification, a chart, or pictures or illustrations, or a bone found in the dirt that's inherited sperm and egg. No, genes, traits, genetics. That's what's inherited sperm and egg, Matt. So I'll start here. I'll kick us off, and then we'll hand it over to you. I know we got a ton on this section because it is important to deal with as they keep continuing to prop these lines of evidence up as evidence that we are related to banana plants, whales, monkeys, and chimpanzees, essentially. So according to Erika here, we are monkeys. And Erika says this is incredible. In one video that we made, which still makes me laugh to this day, Matt, is that Erika stated that, you know, when you're at a zoo and you look at the chimpanzee, it's like you're staring back at yourself. I mean, they're just that close to us, right? And like most evolutionists, though, it's not Gutsick Gibbon's fault entirely here. They put way too much faith in man-made classification systems, okay? Does the chimpanzee or the gorilla or the lemur, do they really care where and how we classify them? Of course not. Okay. We oftentimes point out that far too much money, time, and energy has gone into classifying the biological world. It's nice, it's great, but classifying biological organisms does not prove relationship. We classify and organize things all the time. I organize my books upstairs according to their respective categories, right? I got a whole bookshelf or bookcase upstairs. These are just a few of the books that I have, and I'm constantly organizing them as I get new books in. I'm organizing them according to the type of books that they are. And, you know, I've got books on evolution, creation books, apologetics books, theology books, soteriology related books. This doesn't prove that since all the books use the same 26 letters of the alphabet, and all have a certain percentage of similarity in terms of the words used, the topics discussed, and so on, does not prove any kind of relationship. All this proves, right, Matt, is that we can organize and classify things based on similarities, traits, characteristics when it comes to books, you know, specific topics. And I'm going to share screen in a second for some visuals on this to help it be understandable to everybody. But if I were to draw a circle big enough that was called, let's say in this case, books, then every single one of my books, regardless of the category that they are, would fit within that giant circle, would fit into one giant category called books. But once I narrow my focus onto books that, let's say, only have to do with young Earth creation, well, now not every single book is going to fit within that circle or group. Okay. Although all of my books that are young Earth creation books would fit into the group or category young Earth creation and books in general, they would not be grouped within my, let's say, theology books or books dealing with specifically one category or subset of theology, like maybe the Trinity, or what about my, nursing books from, my college days. All of these subcategories of books will still fit in the greater book category, but each will still have their own subcategory, groups within groups patterns. That's what we see. That's what we see in the biological world. And yes, as Gutsick Gibbon was pointing out, we are covered in hair. We are endothermic, which simply has to do with how the human body and its chemistry regulates our temperature and keeps it constant. Right? And virtually all mammals are endothermic. Again, the various types of creatures within the greater mammal group does not really care that you can classify them, nor do they care where you classify them. Yes, a pattern exists. This is a groups within groups pattern that we see, although there are some inconsistencies, and we're going to go over those later. But we do share more with the great apes and primates in general. Okay, we share more with the great apes and primates than we do with fish and bacteria. Who cares? I mean, so much time wasted on these types of arguments that demonstrates there is a pattern to life, but what produced that pattern? Why is that pattern there? Okay, classification systematics, phylogenetic systematics does not actually answer this question. This does not prove relationship any more than the fact that my books on young Earth creation, theology, and soteriology can be grouped together in a greater group of books called books on Christianity or Christianity-related topics. The existence of a pattern, right, Matt, does not tell us what caused the pattern. That's where we need to get into the differentiating lines of evidence. If I were to argue all day that, creation is true because the sky is blue and the earth is round, evolution's false, creation's true. No, that wouldn't make any sense, because evolution can also explain why the sky is blue and the earth is round. It's agnostic. It's non-discriminatory lines of evidence and observations. We need to look to that which can differentiate between the models, and that's what we are going to get into later. So when it comes to classification systematics, we are, as Erika pointed out, haplorine primates. Wow. She didn't really go into the specifics, but yes, we have a dry nose, and so does the chimpanzee, and so do the monkeys. Again, this doesn't prove anything about relationship. We're also catarrhine because humans and chimpanzees and other similar creatures have nostrils that are close together and directed downward. Wow, that must mean that humans, chimpanzees, and banana plants are related. No, this is great observations. It's great to classify things. This doesn't really mean anything. They'll use these fancy words without really explaining, what it means. And what it means, again, doesn't tell us why there is a pattern. It doesn't tell us why we can classify things the way that we do. Okay, apparently we are related to the chimpanzee and humans, and chimpanzees are also related to banana plants and mosquitoes because we can classify things according to characteristics, traits, so on, and so forth. Matt, for now, before I share screen, actually, what are your thoughts so far, brother, on what we're hearing related to taxonomy and so on?
I agree. It's they're too busy looking for absolutely only the similarities. They're discounting any of the differences because their goal is different than our goal. They want to connect everything because that's what they're starting with their presupposition, right? It's the conclusion driving the paradigm. So therefore, who cares about these big differences and small differences? We got to look at what matches and just throw everything else away. That's how they're classifying. So it makes sense. But before we move on real quick, I noticed that someone named B. Enos gave you a $10 super chat. So thanks for that one.
Well, I appreciate the support. As we always say, you guys are the life and blood of this channel. You guys are the reason why we're able to do this full time and put out full-time content. So God bless. I appreciate that.
And one thing I wanted to state real quick about Carl Linnaeus is he actually didn't categorize humans alongside of apes with any idea of an evolutionary link. he did it with the same reasoning he used to categorize all life, which is that there are similarities he identified between species. That was it. They conflate this and they move it into their model, but they're just borrowing from ours. Because again, creationist, he believed there were separate created kinds, but you gotta, twist words around, right? So, a matter of fact, think about what she always says. Matter of fact, remember when she was so adamant when somebody said, you're a monkey? She goes, no, we're not. We're apes. Apes don't have tails. You're an idiot. Guess what? This interviewer said, am I a monkey? She goes, yeah, of course you are. Oh, great. Okay, so now none of that matters, right?
Well, according to the law of monophyly, I mean, we're still fish, right?
Yeah. Oh, go before.
We never outgrew our ancestry. I mean,
yeah,
we're still whatever our ancestors were. I mean, eukaryotes, right? Whales and pine trees, both eukaryotes. So, that means we're related. And one thing, I apologize for interrupting you. I might as well go over these visuals real quick, brother.
Do it.
Then take your time. Is notice this. You draw a circle big enough, Matt. Let's call this one things that breathe. We're going to be able to fit a whole lot of organisms in there. We got a lion, a bat, a platypus, a horse, a little baby, a gorilla, an ostrich. Okay. Just because you can categorize things in a group and that group is a circle titled something like things that breathe doesn't prove that everything within that circle is related. Well, look at this. Things affected by gravity. You got a bowling ball, the planet Earth we could throw in there. We got a frog, a person, a chair. Okay, shoes. No, that doesn't prove relationship just because we can classify things. Motorized transportation. Well, guess what? Now you've got a boat, a truck, pickup truck, okay, delivery truck, airplane, motorcycle. I mean, we could categorize things as non-powered vehicles or powered vehicles. Okay, so your non-powered vehicles can be separate. You can have like a bicycle or a tricycle or a skateboard. And then in your powered vehicles, you could have a truck, a boat, you could have an airplane, you can have whatever, an SUV. But then if we make our category, vehicles that have wheels, well, now suddenly the non-powered vehicles and the powered vehicles can be grouped together. It doesn't prove that the non-powered vehicles and the powered vehicles are related somehow. It doesn't prove relationship, okay? Just like here, we have a boat built for the ocean. Okay, where that's the perfect environment for it when it comes to military firepower. We have a tank built for land. Okay, I mean, the tank would not do good in the sea, and the boat would not do good on the land. But we've got the perfect intermediate that is designed a military, an amphibious assault vehicle. Okay, military amphibious assault vehicle that's actually built perfectly for the transition from what? Sea to land. And guess what? According to the evolutionists, because this fits nice and neat in the middle, apparently that proves relationship. No, these lines of evidence are agnostic. And I just wanted to give the audience visuals that, yeah, we can, the audience can have some fun. Draw a circle really, really big, guys. Pick a category and just start tossing things in there. It's a good observation. It's fun. It's probably a waste of time and energy. And money when it comes to the evolutionists and the evolutionist community. It doesn't prove anything. Matt, I apologize. Go ahead, brother. Take your time.
Okay, no big deal, man. We're always trying to say, if your best evidence is classifications, because by the way, as you're going to see later, it is. R. and Ross said the same thing to Ken Hovind when Ken's like, give me your 3 best evidence. Number 2 was cladistics and taxonomy. So it's a naming system invented by creationists who didn't even believe in evolution. And if you try to use it, if you're an evolutionist, you actually run into what's known as the taxonomy boundary paradox because nothing converges. There's individual lines of ancestry. So anyway, what I found ironic about that first couple minutes is that she admitted her bias and hatred for young earth creationists multiple times. And we can even read it. But the interviewer said he met her at something called the Faithless Forum. So I want you to ask yourselves, who goes to those kind of places, right? And then if you go into the comment section, you just scroll down. I did it on like the first day. I haven't been back, but I'm sure I could find more. One guy named Mercedes Walt said that he discovered Erika on the Pagan podcast. So, she's only going to anti-Christian, anti-theist places. and she's using evolution, her belief system, and that's why she's so offended that we attack it, because it's just her belief system, and then has set her mind and attitude and everything against us, right? That's why it's so funny when she made her videos a long time ago. She said for a little bit that, I'm not interested in the young earth creation versus evolution debate, and this isn't going to be my full-time thing. She even said it on the podcast that, I just did this for a little while, now it's for life. She admitted she's going to be doing this forever. Of course she is. She's bent out of shape of this. She's mentally distraught that there's another theory out there in conflict with what she wants to believe is true. But then again, you know why? Because she's put all of her money, time, and wants to go get a degree and work with monkeys. So there you have it. And yeah, you're sharing my thing that I wrote up for this, which is everything time stamped and ready to go for everybody, so they can actually get a hold of this and scroll through it themselves and see every single thing.
And notice this, and this is why I screen shared this, because I know I was going to be in charge of the screen sharing today, brother. So you want me to screen share anything from the document that will be available at some point once we go through it and edit it a little bit. Just let me know and I'll share the screen. But the more you include into your groups, right, the bigger the circle gets, depending on what the characteristics and traits you're looking at, right? The evolutionist wants to say, well, the reason why we as human beings are more similar to the chimpanzee than, let's say, we are to the fish or the salamander or the lizard or the mouse. These three are all mammals, right? And what we look at is shared derived features or shared derived synapomorphies, to get fancy. The reason why apparently is because of time, right? The chimpanzee is our closest cousin, according to the evolutionist model, which means we share a more recent common ancestor with the chimpanzee, right? Common ancestor to the chimpanzee here. There's a split. Humans go one way, chimpanzees go another. And the time that separates the split, differences accumulate. So the differences are essentially time. And we would have split from a common ancestor with, let's say, a mouse or a lizard way, way, way into the past, millions and millions of years ago. And so the evolutionists would say that fits. Descent with modification, these groups within groups patterns, nested hierarchical patterns. The reason why we share more with the chimpanzee and the mouse is because we've split from a common ancestor with the chimpanzee not really that long ago as compared to the mouse. But again, as we discussed earlier, this is exactly what would be expected according to the design hypothesis, okay? And I've done a ton of debates lately on this specific question, and I always ask, I say, well, why does the sedan share more with the SUV than the sedan shares with, let's say, an airplane, which are all still fall within engine-powered vehicles? Now, if we were to just say, vehicles or ways to get from one place to another that have tires or wheels, well, now we can bring in the unpowered vehicles. Apparently, a sedan and an SUV, right? There's different characteristics and traits we can look at and features. But the reason why the sedan shares more with the SUV is because we've split from a common ancestor. Not really all that long ago as compared to, let's say, the sedan and the bicycle or the airplane. And what's funny is, Matt, if the chimpanzee did not exist, because there's still a huge gap between a chimpanzee and a human, but if the chimpanzee and, let's say, the bonobo didn't exist, well, then they would still conclude common ancestry because, well, humans are so similar to the gorilla. Or if the gorilla didn't exist, well, humans are so similar to the orangutan. Right? So there's still going to be these groups within groups patterns. They're just going to say, well, the reason why a human shares more with the gorilla, or let's just say there were no gorillas, the human shared more with the orangutan than it does with a mouse, is because humans and orangutans split from a common ancestor more recently than the humans and the mouse. You see what I mean? So it's fallacious. Again, there's always going to be a creature that's more similar to humans. Okay. We're built with the same building blocks. The phenotype is a reflection of the genotype. Okay, so we're going to have to share more in terms of anatomy, morphology, physiology, and genetics with some creatures than others. And it's like these evolutionists, it's ridiculous. They think that humans apparently should be equally distant to all forms of life, equally distant in terms of morphology, anatomy, physiology, and genetics with the chimpanzee and the mouse. I mean, that's ridiculous. Okay, this would not be expected, of course, from the design model. I just wanted to cover this reference here, Matt, and I'm going to hand it over to you, brother. However, it doesn't take much reflection to see that YEC and evolution make the same prediction about the relative genetic hierarchies found in nature, right? We can look to hierarchies in anatomy and morphology, but also in genetics. We can look at hierarchies in the mitochondrial DNA. We can look at hierarchies, heck, even in endogenous retroviruses, various pseudogenes. Under the YEC model, God designed the entire universe, including the various kinds of biological life that exist in it. And we would expect to find that life fits a design pattern. Since humans are made in God's image, we can get a sense for what kinds of design patterns God may have used by examining the patterns that result from human designs. Examples of nested hierarchies abound among the design things in our world. For example, design means of transportation easily fit a relative hierarchical pattern. This fact is unequivocal. Sedans resemble SUVs more than they resemble tractor trailers. And all three vehicles have more in common than do sedans and amphibious assault vehicles. The latter two vehicles have more in common with one another than with submarines. And this simple pattern matches the type of hierarchy that we see in biology. Yes, a pattern exists, but pointing out the pattern, okay, does not tell us what produced the pattern. And that's why we are going to demolish this video when we get into the differentiating lines of evidence, specifically in genetics. Matt, over to you, brother.
No, I think we should probably move on. That was good. We're just 2 minutes into the video, probably. So,
all right, here we go. Let's move on. Good to see everybody in the chat, by the way. I just stopped sharing screen. So good to see over 70 people here. Tag us with your questions if you want. Of course, we'll do our best to get to them, although we have a ton of material to get through. So here we go.
And when he was faced with where to put humans on the tree of life, and I'm paraphrasing here, but he has this famous quote where he says, I would bring down, the ire of all the theologians, if I were to say this, but I can think of no reason by which to separate man from simian and simian from man. And he said this when he got to, get a gander at not only a human skeleton, but the skeletons of these other apes, right? We are what they are, and everything that is unique morphologically or physically about us is just a tweak on an already existing structure. We exist on a gradient with the rest of these incredible animals. And there are, of course, things that humans do that are unique, but they are a product of smaller changes that exist in us physically.
So the hair on our arms and legs and chest, etc. This is a holdover from my primate relatives, yeah?
It certainly is. In fact, you have the same number of follicles on your body as a chimpanzee does. Our hair is just finer. I'm female, but I still have hair on my face. It's just very fine. You can't see it. And like chimps, the only place that we don't have hair is the palms of our hands and the soles of our feet. We are, grossly enough, primarily different from them in that we are sweaters. We are sweaty apes. The reason that it's proposed that our hair went by the wayside is for thermal regulation running on the open savannas, right? We have 3 times the eccrine glands or the sweat glands that a chimpanzee does, which makes sense. They're hairier than us, and we lost most of the hair, at least in its coarseness, right? It's still there. You just can't see it as well. And we are just incredible runners and sweaters. And this is thought by some to be a driver of human evolution, the ability to run for long periods of time, a tradition that's held by hunter-gatherers that live in Africa to this day, which is incredible.
So, what are some other examples of the evidences of my relation? I've heard wisdom teeth have to come out because our jaws used to be larger. Is that true?
Yes. Interestingly enough, though, if as a human, there's a complicated aspect of kind of this phenotypic plasticity that goes along with that. If you eat hard foods as a child, you actually are less likely to have your wisdom teeth, being required to be removed, which is why most people who
All right, let's end it there. Phenotypic plasticity. Pretty soon, I believe we're going to get into more of the genetic related lines of evidence. So, Matt, over to you, brother. Over to you.
Yeah, how far in did we get on that one? Was she a couple minutes in? Because
yeah, we did another. Let me see. So far, we're at 6 minutes and 20 seconds.
Already. Wow, incredible. Okay. Let's see. I don't want to bore people, and I can't screen share, so it's kind of driving me crazy. I was ready for visuals for everybody. I even moved all the visuals over to my laptop so that I could share them, and I can't do it because
I'll screen share for you, brother.
I wanted to just scroll down to yeah, perfect. You're down here with me, with Kent. Perfect.
It looks like some others made their way in, eh?
Yeah. Good. Let them read it.
No
Read
worries,
it
no worries.
Read it and weep. But yeah, here's the introduction into cladistics. Look at how they admit that it starts with assumptions. The definition of phylogeny is the assumption. So you can't do any of these taxonomic labeling and groupings without starting with the assumption of evolution being true already to begin with. And that's what we're questioning. So why in the world would we start with their assumption when that's what's in question? And look, here's, like I told you, R and Raw right here saying that his top evidence, number 2, is taxonomy. Ironic, right? Same thing as Erika. Well, we know they talk, of course. So, so funny to me that the most subjective thing of all is one of their best evidences. And then number 1, evolution happens. You talk about equivocation, right? Okay, what does evolution mean? So they want to break it down to the most trivial thing that it could possibly mean. Change. Therefore, it's true. It's ridiculous to me, but it's what we expect from these people at this point. We like genetics, we like biology. That's what evolution is. That's why when we start our debates and we go, what's the best evidence? They jump right over to the fossil record, where guess what? There's no genetic evidence. There's no DNA. There's none of the things that they can actually prove or connect any of these life forms together. So it's where they can story tell the absolute best. So I just wanted to remind everybody that where their starting point comes from is the problem. You can't start with a false premise, work backwards trying to prove it, and then say, there it is. So what they're doing is they find like a phone, for example, and they go, okay, this was obviously made by aliens because I can't make this. I don't have the ability to make this phone. And then they ask 50 people, can you make this phone? They go, no. So clearly something else made it, right? No, you're starting with the wrong pretense. You're the conclusion. And then you're driving going, well, there's the evidence. We have the evidence. We have the phone. So it's clear that this is true. That's what they've done with evolution. They take the evidence and then they build a story around it. Exactly what Darwin did after taking Lyell's book and reading it and going, oh, I love the deep time. I'm going to take my father's work. I'm going to bounce it off of Lyell's made up geologic column, and then bingo bango, we have ourselves evidence for this story that I can just wield around everything. So I just think it's a big game, and everything else refutes it, as you guys are going to see, because we're going to go through this document and it's going to make him look really bad. So over to you.
Yeah, good points, brother. We're going to get into a lot of the differences between humans and chimpanzees that they can't account for. These major gaps, right? And what we see is discontinuity, and we're going to get into that. A couple slides here. Similarity may not be due to common ancestry. In evolutionary theory, convergence refers to the origination of identical or highly similar structures through independent evolutionary pathways rather than inheritance from a common ancestor. Darwinian theory attributes convergence to similar environments that apply similar selection pressures and thereby produce similar structures. See, here's the thing. Anytime that convergent evolution is invoked, it is actually an admittance into the lack of uniqueness of the universal phylogenetic tree, right? This explanation is on its face implausible. Notice this, because there is no reason to think that Darwin's opportunistic mechanism has the fine discrimination to produce virtually identical, notice this, complex structures, as if it isn't difficult enough, right, to build through selection and mutations and other various mechanisms. And apparently through convergent evolution, the eye has evolved dozens of times, possess many complex features in causally disconnected environments, yet organisms possess many similar features not thought to arise from a common ancestor. Convergence is a widespread fact. As a result, even if Darwinian theory were true, one could never be sure whether similar features shared by two fossils, okay, notice this is important, resulted from convergence or from common ancestry. If similar structures can evolve and re-evolve repeatedly, then fossils can. This is why fossils are low quality, low confidence evidence and data. Okay. Because, and I frequently point this out, today in extant organisms, we know that there oftentimes exists more variation, more diversity within the same species, right? Kingdom, phylum, class, order, family, genus, species. There exists more variation within the same species, think Canis domesticus, for example, than across species or between species. So when you're looking at a bone in the dirt, you're looking at these isolated fragments. How can you tell the difference between homology and convergent evolution? Okay, you can't really. There's a lot of guesswork. There's a lot of inference. Remember, fossils are fickle, and a bone found in the dirt will sing any song that you want it to sing. Okay, re-evolve repeatedly, then fossils cannot distinguish convergence from common ancestry, and tracing evolutionary lineages in the fossil record becomes impossible. That's why, again, genetics is the best way to determine ancestry. Not to mention evolution lacks a mechanism. And we talk over and over again about the problem of genetic degeneration. We've put out article and book and video after video demolishing their very best responses, and they haven't refuted them. Okay, and we've got them all listed in a playlist. You know, so somebody like Erika would say, oh, genetic entropy is not a thing. Even though their best rescue devices, we've demolished them all. Okay. Cladistics and nested cladistics examines arbitrarily selected character traits, arbitrarily assigns value to them, and attempts to build a family tree for a given set of organisms based on statistical similarity. It separates these organisms into groups called clades, forming what is called a nested hierarchy. Nested hierarchy in particular is frequently cited as evidence for evolution, even though, as we went over for about 15 minutes earlier, a nested hierarchy is consistent with the design hypothesis. And even if you remove the chimpanzee, the bonobo, the gorilla, you're still going to be left with, let's say, an orangutan, which they're going to say we are the most similar to anyways. There's always going to be a creature that another creature is more similar to than another, okay? Is it really a surprise that humans and chimpanzees share more in a number of things than a human and a fish? I mean, it's very unsophisticated argumentation from the evolutionists. This is because organisms presumably naturally fit into one another, like Russian nesting dolls, each one fitting into a larger nested hierarchy. This is something evolutionists assume should not be the case if animals were created. The nested hierarchies are arranged in something called a cladogram or phylogenetic tree. And I just want to go over this part here. In fact, cladistics assumes evolutionary ancestry by default, and they admit this. They assume a tree exists. They assume whatever organisms they're looking at go back to a common ancestor before doing their work. It's an automatic assumption. They assume evolution to prove evolution. They admit this. It must in order to work. Notice that. The whole point of cladistics is to determine relationships between organisms and groups of organisms over time by building a phylogenetic tree. There are whole books written containing attempts to do a cladistic analysis on all life forms. The method is designed to look for common ancestry, and nested hierarchies cannot be produced without this assumption. They have to assume this. Assume evolution to prove evolution. It's circular. This can be illustrated by the many cladistics articles in the literature that attempt to determine common ancestry of separate groups. Notice this from evolutionnews.org. The first and primary assumption of all evolutionary phylogenetic classification methodologies is that common ancestry is true. The assumption always goes unquestioned, even when the data doesn't support it. As Elliot Sober and Michael Steele explain, it is a central tenet of modern evolutionary theory that all living things now on Earth trace back to a single common ancestor. And this proposition is central because it is presupposed so widely in evolutionary research. They acknowledge that cladistics assumes that a tree exists and common ancestry is correct. And as you guys are going to see later, the data strongly supports separate ancestry rather than universal ancestry. This is the last quote I want to read on this slide. Whether one uses cladistic parsimony, distance measures, or maximum likelihood methods, the typical question is which tree is the best one, not whether there is a tree in the first place. They're not questioning the tree. They're not questioning the tree itself. The key assumption made when constructing a phylogenetic tree from a set of sequences is that they are all derived from a single ancestral sequence. And we could go on all day with these quotes and this data. I wanted to point this out as well. That is a major problem for them is homology and homoplasy. Evolutionists say that similarities undeniably point to common ancestry, but this is clearly not true, as has been shown. Because close similarity is frequently found in creatures, notice this, where evolutionists concede that common ancestry cannot be the explanation. I've been watching a ton of dialogues, Matt, you have as well. I've sent you some good ones, between paleoanthropologists who have differing opinions. And it's like an in-house debate. And these things are fascinating to watch. And they very frequently point out, like, listen, how do we know this feature, this bone found in the dirt, let's say if they're trying to compare basal traits with derived traits, you know, how can we really know what is the result of homology or what is homoplastic? What is the result of just independent evolution, convergent evolution? They don't really know. They kind of have to just make guesses and then go from there, right? But this is clearly not true, as has been shown, because close similarity is frequently found in creatures where evolutionists concede that common ancestry cannot be the explanation. This observation, this truth is much more consistent with the design hypothesis, guys. Despite this, evolutionists even define homology as similarity due to common ancestry. At the same time, homoplasy is defined as similarity due to convergent evolution, right? So everything's evidence for evolution, even when it's a contradiction in the phylogenetic tree. At the same time, homoplasy is defined as similarity due to convergent evolution. Hence, in the thinking of evolutionists, similarity, notice this, with common ancestry is evidence for evolution, and similarity without common ancestry is still evidence for evolution. So no matter what they find, it's always evidence for evolution, because they assume evolution. They have to assume evolution for it to work. Assume evolution to prove evolution. It's circular. It's garbage. It's unsophisticated. Homoplasy is no more than terminology masquerading as an explanation. You know, the emperor's new clothes. The concept of homoplasy is not derived from scientific evidence, but from blind faith. This faith rests upon the arbitrary assumption that natural processes can explain everything. If you can't tell us how it happened, don't tell us that it happened, okay? You don't have a mechanism. You can't provide us. They've tried over and over again. Provide us one type of natural selection that can rid the population of so many, you know, nearly neutral, low impact, deleterious mutations that are accumulating. They can't. If they can't tell us how it happened, don't tell us how it happened, because that is them forcing their interpretation on the data when it comes to these reconstructions, these historical reconstructions. No, they can't be true, because here in the present, we know that you have no mechanism. You can't tell us how it happened. So quit telling us that it happened with illustrations and fancy charts and fancy trees and fancy words and classification systematics. None of it means anything. Okay, time to get sophisticated here. And I wanted to show this, Matt, and then we're going to move on. Here's a visual. Ichthyosaur, which is a reptile, a shark, which is a fish, and a dolphin, which is a mammal. These similar traits, these streamlined bodies built for their environments, okay? Guess what? Even the evolutionists will say these characteristics, traits, and features evolve separately, not due to common ancestry. Streamlined bodies and fins provide a big advantage for them, allowing them to swim faster. We know that dolphins and sharks, this is from Evolution Berkeley, we know that dolphins and sharks are not closely related, and they did not inherit their similar body shapes from a common ancestor. Yeah, it's almost like they were designed separately, independent ancestry. Isn't that fascinating? Their streamlined bodies, dorsal fins, and flippers are the result of what? Convergent evolution. So if it's similarity not due to common ancestry, it's evidence for evolution. If it's similarity, if it's homology, still evidence for evolution, right? Because assume evolution to prove evolution, guys. And we could go on and on and on this. Trust me. I've got probably about 5 slides of like 50 examples of convergent evolution, echolocation systems being one of them, various different types of complex proteins. All right, there's something called incomplete lineage sorting, where depending on the gene that you look at, you're going to get totally different trees. But for sake of time, we're going to move on. But I'm telling you, I could do a 4-hour presentation on this, guys. And I'm already winded. So Matt, go ahead. What are your thoughts, brother?
Yeah, my thoughts on that are basically the same thing. They predicted Darwinian gradualism over time, right? It's clear that's what they needed. They even showed Darwin's original tree that he drew in his book. Then they realized, there's 3 different domains of life, so that's obviously dead. So what can we do? So they started looking at the fossil record. Everything was contradictory, right? So they had to go, well, there's examples of where evolution moves extremely fast. So they invented rapid radiation and then punctuated equilibrium. Then they found things that didn't evolve at all. So they invented stasis. Then they all of a sudden looked around and go, well, there's not enough noise to classify these. Just throw them over here. And then they said, well, there's horizontal gene transfer probably happening. And, that's recombination, right? Or, don't worry about this one. That's incomplete lineage sorting. We'll deal with that one later. So you see what I mean? Like you said, contradictions abound. They're everywhere. So it's just kind of ridiculous when they make a prediction and then they find everything else that counters it. And it's not a falsification. All they do is just brush it under the rug and go, oh, we learned more. So it's just really more embarrassing for them than anything, because me and you remind them of this, and we show them like, hey, there's a better model that exists. And that's what really matters, because we can kick holes in evolution all day long. I mean, half the evolutionists have already done it for us, but we just want to replace it with something better that actually makes falsifiable predictions that actually work. So go ahead, brother. So you want to share something?
Now, do you want me to share your information here on body hair on humans?
Did Erika mention that, by the way, in that last clip?
Yeah.
Okay, yeah, absolutely then. Because this is one of those things that I think she just jumped to conclusions real quick, right? More storytelling. And she was real quick to just say, oh, look, there's no difference. We can't find a difference between our hair and their hair. Well, not only can we do that, it's like saying a forensic investigator couldn't walk into your house to determine what happened, and there's just a bunch of hair and blood everywhere, and the forensic investigator would be so worthless and so useless at doing their job they couldn't even identify between a monkey or an ape or a human being hair, right? Of course they can. Of course there's a difference. But she wanted to make it sound like, to that audience that doesn't know anything, that there is no difference and they can't tell. So I clicked on the timestamp for you so you can share with everyone.
Oh, are you done, brother?
Yeah. I was just gonna say, so you can share, with everybody. You can just hit that timestamp I got in the private chat and then share your screen.
All right, here we go. Let me put it into a separate window here. Okay, are people apes? This one? Okay, here, let me share a screen. And then you just let me know when to end it, because I'm going to be on mute so there's no echo.
Okay.
Having taught forensic science for many years, as well as worked in a crime scene unit, I'm really interested in those properties that make us unique, especially which distinguish humans from other things that we see in God's creation. Well, we're going to be looking at forensic hair analysis and the distinct differences between human hair and properties that we see in animal fur. We're going to look at the 3 basic parts of an individual hair, and that is the medulla, the cortex, and the cuticle. All right, the cuticle is that outside protective coating that does make your hair waterproof, and it has other features like that because God's very smart. He thinks about that. All right, our cortex is where we do find our cells and our melanin color, and then in here is something we call the medulla, and it's basically what they call an airspace. But here's where we find something very important that we can look at under the microscope and distinguish between animal kinds. There are 3 basic medulla patterns, all right? And that is continuous. Now, in a continuous pattern, we see this solid black line running up through the center right here, all right? In a fragmented medulla pattern, all right, we can see where it's actually broken. It's almost like Morse code. It actually looks like dots and dashes running up the center of the hair shaft. And then some people actually what we call absent, all right, where you literally just don't see a pattern in the medulla at all. Sometimes you'll see a hair sample that looks like this, where the medulla is a little more present, but you still don't see a distinct continuous or fragmented pattern running up the center of the hair shaft. Now, these are all human hairs that you see here. What we're going to find, though, when we go look at animals, it is distinctly different. All right, another reason that we use hair, and the primary reason we would use it in forensics, is because it has the potential to provide that unique identity, all right? So one important distinction I like to make is, especially in the presentations that I give here at the museum, is that we find hair in humans, right? We are made in the image of God, and we are distinctly different than the other creations that do have what I like to say is fur, all right? So we do find fur in animals, and we do find hair in humans, and we're going to see there are distinct differences between those two as we move through the presentation today. So what we would hope to get from finding a hair sample is that DNA fingerprint that we call it, being able to find viable DNA, and we would refer to that as nuclear DNA, which is found in the nucleus of a human cell. We can also determine hair color very quickly. We can even roughly get an idea of someone's, what we say, ethnicity or people group from that hair sample. So we need to talk just a little bit about the distinct differences between human hair and animal fur, all right? Because evolutionists like to say, well, because we share these traits with animals, it's part of that evidence they like to call that we descended from a common ancestor. And that is just not the case, all right? God equipped us each with exactly what we needed to survive in our environment. So if we take a look at human hair versus animal fur, one thing we're going to see a difference in is growth. In humans, as I said, our hair is continuous and it is independent, meaning it's all over our head at different times and at different stages. Whereas in animal fur, it is stopped and it is synchronized, all right? Especially in animals, if we notice in the winter, especially when it's up in the areas where it's colder, they're going to get much thicker, right, in their fur. Then in the spring, what happens is they start to shed, right? You start to get fur, especially my cat sheds in the spring. I get cat fur all over my house because he is shedding that. And they do stop. Their hair does stop growing at very distinct stages. I mean, does a cow need to go to the hair salon? No, right? God equipped them to have their hair stop at a very specific point. Also, diameter. In humans, on average, the diameter or the thickness, we would say, of our hair is much thinner than we are going to see in animals. Also, our medulla patterns are thinner. We're going to see this when we look at our pictures here in just a second, that animals have a much wider and more prominent, we would say, medulla. And as far as our texture, in humans, on average, our hair is soft and has potential to grow very long. But in animals, it is coarse and often very short, right? Now, there are rare exceptions because we have purposely crossed certain traits, especially of dogs, to have long hair. But that is not how they would normally exist in nature. Also, temperature regulation. In humans, our hair provides us absolutely no temperature regulation whatsoever, all right? In the winter, does your arm hair keep you warm, Mr. Patterson?
Not really.
No.
I usually have to put on a jacket or
Yeah.
something.
Does our head hair keep us warm in the winter?
It does, yeah, because it's a lot thicker, but it's
But
still,
what do we have to put on if it's
we gotta put on a
snowing?
cap if it's that cold, because it's
Right.
still a little thin and things can penetrate.
Right. So in the winter, you still have to put on that hat, right? Because it is not going to keep you warm. Your leg hair is not going to keep you warm, right? But what about animals? Absolutely, right? God designed them to thicken up in the winter, thin out in the summer when it's warmer, and their fur is specifically designed to regulate their body temperature and allow them to live outside. And color is another distinct difference. In humans, on average, we have constant hair color, all right? That's not to say we may be lighter brown in the front or darker brown in the back, and we do get gray because our cells die of color. We just don't produce color anymore. But on average, it's constant, right? You're never going to see a human with naturally growing zebra stripes, right, in their hair patterns. You're never going to see a human who has, like a cow, black, and brown and mustard color splotches. God just didn't create us that way. Our hair is a constant color. But in animals, you can absolutely have abrupt color change, sometimes within the same fur sample. Very distinct differences. Now, the FBI even recognizes that human hair is distinctly different. They say in human hairs, the scales form an imbricate pattern. This characteristic serves to distinguish human hairs from animal hairs. Many animal hairs have a very regular repeating pattern to their scales. So even the FBI on their website had to acknowledge that human hair is distinctly different from animal fur. And that's exactly what we expect to see because we are made in the image of God. So we're going to take a look at a few samples now, all right, of animals and humans side by side. So this first example is a primate sample, four different samples of primate fur next to samples of human hair. Remember we said human hair, their medulla pattern is thinner, and we can see that in evidenced here. Remember the medulla is this pattern that we have running up the center of the hair shaft here. Now, if you take a look, you're going to see the distinct difference between human and animals, all right? If we look at the medulla pattern of this primate right here, this pattern running up the center looks distinctly different from human hair. All right. Primate fur is distinctly different from human hair. There are no similarities at all in their medulla patterns. Very important.
Everything they have to prove that evolution is true breaks down when put under the microscope and when put to the test.
So, clearly when she was saying, oh, it's exactly the same, and then she just moved on, it's not the same. It's not even remotely the same. So it's just more nonsense, just mixed in, thrown out to an audience that's not paying attention, doesn't know the difference. So, if you want to share the screen on the document again, just real quick, so I can show the visuals of the evolutionary explanation for why it's so different. One of them was the being hit in the head. You get hit in the face, and that's why we started growing beards. And that's why chimpanzees do not have facial hair. Apparently, they don't like to punch each other in the face. So, and then as you can see right below that, human beings, their hair, look at that, exactly the opposite in where hair actually grows. So we grow it in the exact opposite proportions than our closest kissing cousin relative. Like that makes any sense. So again, completely different hair and fur. And then if we go down just a little bit more, we can see a human have eyebrows in our eyebrow hair. Primates of none of those have that at all. So it's really a shame to me also that in the fossil record, none of these things are preserved, because those are really huge differences, like the subcutaneous layer of fat that runs underneath our skin that no primate has whatsoever. So just another good example of just complete opposites, complete differences in every way, shape, and form. But, that's why they like the fossil record so much. There's so little bit of evidence for these soft materials and hair and skin and these types of things. They're not there. So they go, they can play around a lot. It's like a playground for adults where they can just puzzle whatever they want together. As you can tell, because look at how much discrepancies there are between views on between paleoanthropologists themselves trying to determine where to place these things. And these are the experts, and they can't even agree. So
right here where it says one anatomical difference between humans and chimpanzees is the human subcutaneous layer of fat, which is apparently lacking in other primates. What would you say, Matt, to play devil's advocate, if they were to say, because you'll notice there's a lot of storytelling, like even in the video with Erika, what does she say? Well, maybe this, maybe that, maybe this is how we got this, maybe this is how we lost that. So if they were to say, well, humans eventually started to live a very sedentary type of lifestyle where you have various primates like chimpanzees, gorillas, these animals that are in the wild, they need fat for energy and they use that up right away, right? So there's no buildup, I guess, of a subcutaneous layer of fat because it's being utilized. The fat is being utilized for energy, for survival things, stress responses, things like that. But for humans, we store fat to be used for energy, but then a lot of humans never ended up using it because of their lifestyles. That's just something that comes to mind. Like maybe that's what they would say. I don't know. You try and think, what kind of story could they concoct with, right? What would you say to that?
Well, we have to think to ourselves, what would be the purpose of when this hair was being lost? Were we getting colder at that time? And then all of a sudden, the tons of mutations started to come in to evolve this whole new system that has to exist throughout the entire area underneath the skin. I can't even imagine how many mutations that would take. And then during that process, we're now getting cold because we don't have it. So now we have to put fur back on. We have to wear fur that we just lost to stay warm while that's a process. And then once it is processed, guess what? We still have to wear clothing to stay warm. So what's going on here? And then sedentary, I mean, look at the chimpanzees in the zoo or in the wild. They don't migrate. They don't travel around. They sit most of their time and just like pick fleas off of each other and live in the trees. So, I mean, even their lifestyle is very sedentary. That's why they're going extinct now, is because their numbers are dwindling down. They're becoming more inbred and they're dying out as well. So clearly, if they weren't sedentary, they would be being able to migrate around and travel around and grow in population size, but we don't see them doing that. So again, they would need evidence for any of the story that they're coming up with to say. And that's why there's other theories that exist. Like, how about the aquatic monkey theory? Primates started spending more time in the water, and therefore that's why they needed the subcutaneous layer of fat, because most aquatic mammals have this layer of fat, and that's why. And that's also how they started walking around too, right? They walk around in the water and they bring their hands up and they start walking through the water, trying not to get wet, and that started bipedalism. The unfortunate part about that theory is Eugene, the guy who started this theory, even admitted that there's no possible way we'll ever find evidence for it, because it would have been in the ocean and it would have washed it all away. So you invented a theory that can never be proven with any evidence, because evidence doesn't exist. So as you could imagine, his theory wasn't taken very seriously because of that. And but then again, it's just storytelling anyway. So his theory should hold as much weight as any other one, frankly. So
it's funny because even in their own lectures and dialogues that we spent a lot of time watching, in the Q&A period, people will ask, like, what evidence do we have for, XYZ? And these paleoanthropologists will admit, well, this is more of a hypothesis at the current time. We don't really have any supporting evidence. This is just like a possible explanation. Maybe this is how we lost this. Maybe this is how we gained that. Did you want to go through the various timestamps leading up to roughly 620 is where we're at, brother? Oh,
wow. Okay. Sure. Again, I was planning on sharing screen. We won't be doing that now.
Anytime you want me to share a screen on the document, just let me know, brother.
It's okay. There's plenty to talk about regardless. Yeah, the aquatic ape theory. Another one of that was why humans lost their hair and became naked, was postulated to because chimps have thick fur, whereas humans have fine, very fine hair, like which was mentioned in that thing. The study counted sweat glands, and there were humans. The humans stood out from this, and the source of the watery perspiration because we sweat from these glands. Then the density in humans were 10 times higher than that found in even monkeys. So again, these are functional differences. This is what we're talking about. So I would have to say that anytime that we're going to look at something for similarities, we should also be looking at differences. From what I can tell, most of these things are looking for similarities only. And that's also one of the problems that I can see with also baraminology, right? So again, we're looking at shared traits and what is the possible placement of these things. Great, but what about the differences? What, instead of like, what does this look like? What does it not look like? What's going on? Just because something might have, for example, you always see the foramen magnum, or the big hole at the base of the skull. That's usually an indicator of, oh, look, it's moving more towards the center, and this is a great proof of an intermediary species. This is what they said about Sahelanthropus sagensis for a very, very long time, is look, the foramen magnum is more near the middle. What they discover? It was nothing but a gorilla the entire time. Its foramen magnum, though, had shifted a little bit, probably because of the lifetime. Things can shift. And if an animal spends most of its time sitting in an upright posture, which gorillas tend to do, then that can change. And it makes it appear as though, oh, maybe it was walking around. And that misconception has led to huge amounts of storytelling. Remember, the first link of the chain was Sahelanthropus sagensis for the very long time. Now, what do we know about it? Oh, they were completely wrong. Another failed prediction. All because of the single thing that they found, that foramen magnum adjustment. That was it. And right there, look, that's the only part that they have of that until recently when they found the lower leg.
You see how much confidence they put? I mean, just look at what Nebraska, was it Nebraska man that they, built an entire species on one tooth? It turned out to be a pig tooth. Or, the Piltdown man fraud. We see what fragmentary evidence, low quality, low confidence science can result in. Here's an interesting quote. Notice this. All this reminds me of the statement made by Nigel Hawkes in the Times, in London, the London Times, September 23rd, 1995. Few sciences, notice this, and this isn't a young earth creationist, produce such abundant returns from so few fragments of fact as paleontology. Remember this when you see the next newspaper report of some new fossil hominid find. You have a right to be skeptical. I mean, they admit to this. I mean, look at these quotes. All new discoveries make things more confusing. This is when it comes to paleoanthropology, human evolution field. The transition to Homo continues to be almost totally confusing. What a mess early Homo is. Here's a paper I read just last night, because there's so many papers and dialogues and lectures to go through in this field, and every single lecture, dialogue, every single paper that you read, there's just amazing finds. I guess they don't think young earth creationists are listening or reading. Look at this. From Australopithecus to Homo, the transition that wasn't. These are a couple excerpts from the paper, okay? Here's a couple links if you guys want to read the paper. William Kimball. Although the transition from Australopithecus to Homo is usually thought of as a momentous transformation, the fossil record bearing on the origin and earliest evolution of Homo is virtually undocumented. We had Dr. Joel Duff in the chat, who's terrified to take the evolution challenge, and who has he's up there as a potential winner of the 2022 Golden Dodgeball Award, because he dodges, he ducks, he dips, he dives, he dodges all over the place. He's mastered the 5 Ds of dodgeball. I mean, Dr. Nathaniel Jensen, he's got confirmed testable predictions, and evolutionism has been overturned, and poor Dr. Duff here, he's not really refuting the data. He's not countering it. I haven't seen any worthy arguments. So He was pointing out earlier, when you've got an AIG source, scoffing at that. It's like, we've got answers in Genesis sources. We've got dozens of secular sources. We've got a mix of everything. Okay. Try and refute it all. And that's fallacious anyways. I mean, ridiculous. The fossil record bearing on the ancestry of Pleistocene Homo, notice this, is poor. The Pliocene hominin diversity conundrum. Do more fossils mean less clarity? Read the paper. You know what the answer is to that, Matt? Can you guess?
Of course it does. Because the more we find, the more confusing it gets, because they made a prediction and then they find something that doesn't make any sense.
Notice this, Bernard Wood. 50 years after Homo habilis, even with all the fossil evidence and analytical techniques from the past 50 years, a convincing hypothesis for the origin of Homo remains elusive. Now, see, I say notice this a lot. You'll notice me saying that in my opening statements and in debates, because I know the short attention span of the evolutionists, and it's just in one ear and out the other, right? Think about how many data points and arguments we presented in the first hour, and the only thing, somebody like Dr. Joel Duff does or responds to is, oh, wow, that's an AIG source. I mean, the level of sophistication is fascinating. Notice this, Bernard Wood's latest tree diagram raises more questions than tree diagrams made over 20 years ago. Wood acknowledges that the hominin fossil record is more convoluted than ever before and still fails to show any hint of a discernible ape-to-man progression. Oh, that's,
shocker.
And we could go on and on about I mean, I'll just do this one. And eventually, guys, I'm going to be doing like a 2-hour presentation on human evolution, going through all of this. So, although there is no doubt that these new fossil discoveries have opened new windows into our evolutionary past, notice this. They have also complicated our understanding of early hominin taxonomy and phylogenetic relationships. Look at this. If we want to be objective, we shall almost certainly have to scrap the iconic list of names in which hominin fossil specimens have historically been trapped. And start from the beginning. Just scrap it all. Go back to the drawing board. Erase everything we got, all our current understanding. Let's start fresh. Let's start from the beginning. Yeah. Those poor souls over the last, 100 years or whatever it is, who just, let's say, blindly believed the evolutionary stories or fairy tales that are now overturned. I mean, are we putting our faith in the wisdom of man? Or are we putting our faith and trust in the power of God? Okay. Because when you put your faith in the wisdom of man, especially when the wisdom of man has to do with this fragmentary data, right? I mean, the whole field of paleoanthropology is contested. It's fragmented. It's disputed. Any find that's propped up, you'll find another paleoanthropologist who is not convinced by it, disagrees with it, so on and so forth. Matt, over to you, brother.
Well, why do you think Erika wants to get into it so much?
Right.
I think that, matter of fact, if you can screen share mine real quick, I want to go back somewhat because I wanted to rewind. You can find it in the document. I clicked on it so you can follow my cursor. You can just scroll up. It was the Smoky Saint comment. And
sloppy saint
right there. Yeah. This was asked specifically by somebody that says, because Erika jumps in right here and says, the last I checked, I was waiting on answers to my questions. I wanted to engage with weenies who try to gaslight their way out of a pinch. So this person says, truth brings people together more than just those stories. Correct. And then down here it says, name the question he never replied to. I went back and checked because this was, almost a month ago now. Guess what? Nothing. Never replied at all. And here's the playlist right below that on how many videos we've actually responded to all of her questions. So I'm just making things up basically at this point. I'm just saying things that don't make any sense. Didn't like our answer, probably is what it was. She knows what our answers are. She just says that we don't give them because she's honestly doesn't want to hear the answer to begin with. That's what.
And how many challenges, guys? There's a playlist titled, I think responding to Erika's 3.5-hour video, where she had Dr. Joshua Stramidas on there, and tried to critique Dr. Nathaniel Jensen's work, so on and so forth. We did a whole series of videos presenting, 20 to 30 challenges, and presented a number of questions, and none of them were met. None of them were responded to. And one of them had to do, we did like a 2-hour show on the Y chromosome dissimilarity between, I'm gonna have to find my slides on it, but between humans and chimpanzees, right? And she looked to sperm competition as one of the reasons why, when you consider overall gene content, architecture, size differences, okay, the Y chromosome between the humans and chimpanzees is only about 35% the same. And it turns out that the human Y chromosome is more similar to the gorilla Y chromosome when you consider overall gene content, architecture, and size differences than it is to the chimpanzee. So she tried to say, oh, the odd man out is the chimpanzee, and gave the same hypotheses that are given by evolutionists who have studied this. For example, a variety of these hypotheses have been presented even in this paper here, the original paper, Chimpanzee and Human Y Chromosomes Are Remarkably Divergent in Structure and Gene Content. We did an entire 2-hour video showing why her answer, her argument, her counter argument fails miserably. Notice this. Here we finish sequencing of the male specific region of the Y. Remember, the Y chromosome is non-recombining, uniparentally inherited nuclear DNA. Okay. There's no recombination. Every single male Y chromosome on the planet, nearly identical. Me and you, our Y chromosomes, nearly identical. Me and, someone over in Africa, our Y chromosomes, nearly identical. Very low variation. And what was introduced by the evolutionary community was post hoc, ad hoc, right? Out of Africa population bottleneck. We spent hours showing why that doesn't work. That's not even feasible. Erika and I debated that, but they had to resort to that in order to explain why there's such low variation in the Y chromosome, the mitochondrial DNA, just our genetics in general, right? Because if we've been evolving for millions and millions of years, accumulating mutations every single generation, there'd be a lot of genes floating around, right? So why do we have such low genetic variation? Well, according to our model, God creates two people, Adam and Eve. That restricts genetic diversity right there. But I don't want to get into a whole rabbit trail on that. So the point is, okay, the Y chromosome should have been the most stable between humans and chimpanzees. It should have been very similar, but yet it's only about 35% similar. Okay, so she can look to sperm competition. She could say the chimpanzee's the odd man out. She can look to polygamous relationships and activity in chimpanzee groups, but without predictions. Okay, if it's just a story, it's pseudoscience. Okay, and we did a whole 2-hour video on it that she dodged, but I'm just going to go over this slide. Okay, before we move on, and people can check out that video in its entirety. Notice this. What are the implications of this new information? First, for the evolutionist, the Y chromosomes must be evolving much more quickly than anyone imagined previously. Now, anytime you see rapid evolution or engines of evolution, you'll see that when we get into a lot of the genetics papers that we have here later. That's just Evo speak for very different, right? Why is it very different? Well, it must have evolved rapidly. Because remember, they don't question the bigger picture. Assume evolution to prove evolution. They are now going to have to, okay, so Erika, okay, you are going to have to apply mathematical models to try to demonstrate how, you can't just say, oh, sperm competition, or you can't just show, levels of diversity within, various chimpanzee groups, which is still nothing compared to the human and chimpanzee Y chromosome, which is 35% similar. That's very, 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 very different. Okay. Especially considering every single male human Y chromosome, 99.999% similar. And we know that the mutation rate in the Y chromosome, human male Y chromosome, is about 3 mutations now per generation, now that we've looked at high sequencing data. Okay. So we have a mutation rate that's incredibly fast in the Y chromosome. and yet low DNA variation. That means the Y chromosome has to be young. That's the only way to explain a DNA compartment that has a fast mutation rate and low variation. The Y chromosome can then not go back hundreds of thousands to millions of years, or else there would be a higher level of genetic variation. This is very easy to understand. You know, Dr. Joel Duff, let's go. This is right from the secular literature. Come on. What's your response? And they can tell a story and they can guess all day, but guess what? Again, you are going to have to apply mathematical models to try to demonstrate how a sequence can change extremely rapidly. Show us how these differences can accumulate. Whole scale differences, whole scale deletions, whole scale rearrangements, including wholesale rearrangement of significant parts in the evolution of entire gene families. Well, sperm competition. You're going to need to do a lot better than that, okay? She thinks we have a heat problem. They have a genetics problem. And guess what? Genetics is the best way to answer this question of ancestry. And genetics has confirmed separate ancestry and refuted universal common ancestry. Okay, you are not related to a chimpanzee. This is just one of the many lines of evidence that we're going to get into tonight. And the evolution of entire gene families in a relatively short amount of time, yet stay homogeneous within a species. Low variation within the human Y chromosome, but yet very, very different across species. So look at Matt. Can you see me? You've got the human chimp, so chimps here, humans here. They go back to a common ancestor, let's say 6 to 13 million years ago. Let's just focus on the Y chromosome. They split. Now think about the massive differences in the Y chromosome. Here's the two lines. I mean, they're now like here and here. Well, sperm competition. You're gonna have to do a lot better than that. Show us how you can get these amount of differences in your 6 to 13 million years. And they say it like it's nothing. Anywhere between 6 and 13 million years. It's like double. 6 and 13 million years. Matt, how old are you? I don't know, somewhere between 30 and 60. Like, give me a break. So, this is going to be very difficult for them. And Dr. Rob Carter, very accurate testable prediction, because it has been very difficult for them. So go ahead, Matt. I wanted to get that in there at some point. So floor is yours, brother.
No, it's all good. Let's play it some more. Let's go from here. Get the next section done.
All right. So you made it to the 620 mark.
Yeah.
We got 90 people in the chat. So you know what? I'm going to give these evolutionists an opportunity here. Let's see. I've had 97 formal debates with PhDs, serious students of evolution, like Erika as well. Nobody has answered this problem of Y chromosome dissimilarity. So let's see. Dr. Joel Duff, Mr. Dodgeball Man himself, says, take some classes and learn a few things. I have a whole, so notice, 0 arguments, 0 counter responses. This is why Joel dodges the evolution debate challenge. Come on. We've had and hosted over 160 debates. What are you waiting for? So let's see. Joel, provide us a paper. You know what? I'm going to give him an easy task. Provide us a paper right now, Joel, or any evolutionist in the chat, that shows a non-functional endogenous retrovirus going from non-functional to something extremely functional in embryological development, determining cell types, regulating genes, functional in terms of the immune response, acting as protectors in as antiviral protectors. These are just a few that come to mind. Come on. Or show us a paper that actually lays out a mathematical model for how we can get such massive differences in the Y chromosome between the humans and the chimpanzees. Come on. We're going to be doing this for another couple hours, so we'll wait. The challenge is out there. 2 papers. Let's deal with endogenous retroviral function and the Y chromosome dissimilarity. We'll send the paper, show us the empirical evidence. We'll put it up on screen, and we'll see if it finally answers the questions that have been dodged. So, Matt, here we go, brother.
Yeah.
Let's
wait a minute. You said 620 was when we stopped at. So that means she mentioned and brought up that jaw size in the past was proof that we're related to them. Well, I have to say, well, think about that for just a minute. The jaw being larger in the past made our teeth line up better because we ate more natural foods. Therefore, we're related to apes. Think about that stretch. Think about that leap of logic right there. So humans' jaws shrank in size because of what we ate, deteriorated our jaw a little bit. Now our teeth don't fit very good. So therefore, this is proof we're apes related to chimpanzees. That's like saying, you know, you and me and primates, we eat the same thing, so we're related. Whoa, 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 wait a minute. We digest those foods very different. So did you ever think about that? Like, those are two different things. We might eat the same thing, but everything about that food through our body is broken down completely different. So again, looking at one thing and ignoring the major difference that matters far more than the similarity aspect. But now let's go on. Now I'm ready.
So this is how people like Joel Duff and Joshua Stramidas read young Earth creationist technical literature. Okay, so you'll notice the paper up on screen here on the laptop or the computer desktop screen is Dr. Nathaniel Jensen's predictions on the Y chromosome. Okay, so this is how they read these papers when they try and refute and scoff at them. You know, so my only recommendation, Joel and Josh, take the blindfold off. And then maybe you'll actually be able to provide a sophisticated rebuttal. Notice this. That's Dr. Rob Carter's hand. I've got a slide on this, but I'll just pull it up here. 1,000 Genomes Project. Okay, this unrooted mitochondrial DNA phylogenetic tree. Any evolutionists in the chat? Come on. Do what Erika and Dodgeball Danster and Cardinal have not been able to do. All right, there's only a few mutations here separating any two people. The mutation rate, okay, is about one per generation. Or one every other generation. Let's give them that. It's a fast mutation rate, put it that way. Yet low variation. About 100 to 120 max between any two people. But on average, what is it, Matt? About 20 to 24, 25. So we got explosive growth from a center point. Exactly what we would expect from the biblical model of ancestry. Right? What do we have? Creation, Adam and Eve, followed by rapid and exponential population growth. Then we have, a couple thousand years later, the flood. 8 people, rapid and exponential population growth. We have some of these subgroups that can be explained by the Babel dispersal. Okay. So guess what? All these branches going back to a center point. Just look at one. I'm not screen shared actually, so you guys can't see my mouse, but HVR, this most common haplogroup in Europe. Notice the differing size lengths. This means that people, okay, are picking up more mutations in the same amount of time than their cousins. That breaks the evolutionary molecular clock. Now you can't look at the DNA differences that separate humans and chimpanzees and say, well, you know, here's a very slow mutation rate. No, the mutation rate is fast. There's low variation. The pattern, one woman, exactly what we would expect. This is not tens of thousands of mutations. This is not tens of thousands of generations. This is a couple hundred generations max. So there. ERVs, mitochondrial DNA phylogenetics, and Y chromosome dissimilarity. Any evolutionists in the chat? Joel, go ahead. There's 3 you can deal with. Let's get some empirical rebuttals. Go. So as they're doing that, Matt, we'll share system audio and we'll keep on going. Another couple minutes here.
Live in sort of quote unquote less developed nations, they don't tend to have as many teeth problems. They eat harder foods and they eat less sugar. So it's not like we've degraded and that's why, you know, we have to get our wisdom teeth out. We just don't eat hard enough stuff when we're young. But you know, your apish heirlooms are all over your body. You're covered in hair, of course. You have the same dental patterns a chimpanzee does: 2, 1, 2, 3, 2 incisors, a single canine, 2 premolars, and 3 molars. Right? You have the same number of rods and cones in your eyes, and your brain is organized in exactly the same way. We have all of the same bones as they do. Again, they're just tweaked and moved in some slightly different directions, and we have all the same muscles. We have more slow twitch muscles than fast twitch, right? Because we're dexterous. We're the best rowers in the animal kingdom. Of course, we sacrifice our strength for that. A chimpanzee is 3 times the strength of a human. A gorilla is 5, an adult male human. But they can't throw, you know, for jack. They're horrible birds. They lob things up and over. We have fingernails, just like they do, just like all primates do, instead of claws at the ends of our fingers. And why is that? It's because when you grab a branch, you don't want to bring those nails into your palm. So we just flattened out the keratin in order to still get the utility, but be able to move through the trees. We have mobile shoulder joints. There's no reason, quote unquote, for humans to be able to raise their arms up like this over their heads, right? But we descend from critters that lived in the trees, for whom this was a really necessary morphologic characteristic. It's all over us. I mean, we share 98.8% of our coding DNA with chimpanzees, and they share more with us, and this always blew my mind, they share more with us genetically than they do with the gorilla. So not only are they our closest living relative, but we're their closest living relative as well. It's inescapable. We have endogenous retroviruses located in the exact same place all across our genome, right? And many of the same breakages. Of course, there are novelties to the human genome, and there are novelties to the chimp genome as well. We are special, but so are they. So is every creature in its own way.
You follow the work of Neil Shubin.
Yeah, I just talked about Neil earlier.
Your inner fish. That's counterintuitive. When I was a believer, I was like, oh, come on, that's just bullshit. There's just no way. Right? I mean, I know that we have a commonality with all living things, including plant life. I would have totally rejected that. Right? But I'm related to a fish, and he had an example, I think, in his television version where they showed someone who had, I guess I'll call it.
All right, we'll stop there. 9-minute mark. Man, we got a lot to deal with there.
Did you catch that?
I'll let you.
Lost our strength so that we could throw spears.
Yeah.
Think about that one.
I wish I had SpongeBob near me. Just imagine. The storytelling as to how these adaptations came about. No evidence, just a lot of storytelling. Matt, go ahead. You can dismantle that first few minutes, and then I'll jump in with my portion.
Okay, so the first thing that she brought up was that we have the same number of teeth, and that is true, but they are different types of teeth as well. The maxilla and mandibles are shaped very differently. We have 2, chimps have 1, so that's interesting. We have the parabolic jaw shape that primates do not have. That shape is very, very unique, and it's just in people. The canines of our teeth are flush and flat with others, and especially when you look at adolescents, the chimpanzees have these premolars that are different, so that when they push on there, they can force the canines down and to extend later in life. So that's also another problem when you find a primate, chimpanzee, or any primate skull that's in adolescence. It looks more human-like because those traits haven't yet set in, where the face starts to really extend and the canines really start to dive down and the foramen magnum really shifts because of the head size growing. So everything about it looks a little bit more human. So they can, again, storytell by quite a bit by doing that. And another one, she said, we have the exact same rods and cones. Okay, so let's just go with that. By the way, the numbers that in that sharing is huge. By the way, so that number is 100,000 to 344,000. So that's what's shared. That it could be anywhere within those numbers, and that means shared. And it could even be exactly the same. We could share. Oh, and by the way, that's just in the middle of the retina. By the way, so we could actually share the exact same number, but what really matters is where those rods and cones are inside the eye. Because if they're in different layers of the eye, then they're for a different function. And as you can see on these charts right there at the top, actually, with what he screen shared, is we are able to see better when it comes to reaction times. We can see things moving slower and faster. The vision of a human being is far better than any primate. So we can react to those things quicker when we see them. So imagine putting a chimpanzee in a race car that has to go around a track. If they had the dexterity to even do it, they would do miserable compared to a human being, because our vision and our sight, even though the rods and cones are the same number, doesn't matter. The function of them is different because they're in different regions and they're concentrated in different placements throughout the eye. So again, functional differences created that way for a reason. So, let's see, what next? What else did she say?
I've got the screen shared too, where in your document you've got these pictures.
Yeah.
These findings suggest that humans were better able to integrate local visual information. So,
right. Yeah. I'm going to go past that one now. I was just talking about that. Our ability, differences. It was a good study, but I put it in the document. Everyone can read through the technical stuff later if they want to. We're just going to cover the kind of fun thing rather than delve real deep into it. I'm giving you an overview. She said our brains are essentially the same at 6 minutes 55 seconds. That was pretty funny. Methylation different, orphan gene different, gray matter different. We actually have rose hip neurons that are only found in human beings. I mean, we have the speech modules in the brain. Everything about the brain is different. So what does she mean the same? That's a ridiculous comment to make. One of the more ridiculous ones. And I believe anyway. Did you have something you wanted to bring up?
No, I mean, only when you're done, and then
all right. At 6 minutes and 57 seconds, she said we have all the same bones. Well, that's wrong as well, because we have the nose bone alone. Right there is instantly proves are wrong then. We also have fewer ribs, but more vertebrae. It's totally opposite in chimpanzees. Chimpanzees have also 31 bones in their feet, but human feet make up 26, 52 in total. So again, completely different number. Did you know when their spine breaks, they can heal it? When our spine breaks, we're done. We're done. Our ribs can regrow. Theirs can't. They have no rib regeneration. Kind of odd that God said he used our rib to make Eve, and our ribs can actually regrow. Kind of what are the odds that ancient sheep herders knew that one, huh? The foot structure is very different. It's not found in chimpanzees. The three arch system that's found in the human being foot. They have a bacillum, or the bone in the penis. Human beings don't have that. Ours is an organ, an actual organ. So I don't know how we lost an actual bone and then evolved an organ through mutation slowly over time to replace that. Like, was there no sexual reproduction during this time, or did it happen just overnight for a generation? Was it just born with that ability? That makes no sense. So only humans have a hyoid bone in the throat region that's for speech. The primates don't have that. So that's another big difference right there. We have a single ligament attached to the ring-shaped in the tibia. What else do we got? How about the bones themselves? Our very bones are different. The chimps have bones that are densely packed with microfiber structures that are strong and spongy, but human bones
Matt,
aren't.
I'm gonna stop you right there just to leave no stone unturned. So if you look at my screen, this is so funny. This again, okay. I mean, this whole team, Team Gutsick Gibbon, just the most unsophisticated responses. So this is what was their argument. Okay, notice this source up on screen. Humans are not even alone among primates in lacking a baculum. Although most non-human primates have one, tarsiers do not, and neither do two groups of New World monkeys. But a penis bone is present in all the New World monkeys and is universal among lemurs and lorises and in Old World monkeys and apes. So we're talking about our closest cousin, right? The chimpanzees and the other great apes. Okay, where we've got that difference in the baculum, right? We don't have a baculum, and yet they want to go as far down the tree as
Monkeys.
Yeah, monkeys. It's like, way to just straw man the separate ancestry model. I mean, we're not the ones proposing universal common ancestry among primates here. We're showing you why, through a number of reasons, humans are not related to the chimpanzees and thus not related to any other, primate. They would just call, the great apes, like the chimpanzees, the orangutans, the gorillas, non-human apes. And apparently we're human apes. But do you? Well, I mean, it's special pleading. Well, I mean, we got this monkey here that lacks a baculum, so therefore maybe humans lost theirs at some point. Since right, it's always about a loss of these structures at some point during the split. So I just wanted to bring that up. What's your thought on that, brother? And then go ahead.
I want them to actually critically think about that and go backwards in time from chimpanzees and humans and to a common ancestor. Okay, so that common ancestor had to dodge all of the, gorillas, Pongo. It had, like, what did it have? It obviously had the baculum, right? So then it got to us, and then there was the split. And then we somehow lost it down our line somewhere, right? That was what they would have to say. Well, that's not much to lose, but it's a whole lot to gain, isn't it? A gaining of an entire organ for reproduction. It's not like we needed to gain the organ for, some trivial thing like to grow extra long hair, maybe our hair on our back or something like that. We're talking about a sexual reproductive organ had to be gained somewhere. So it's not just the simple loss of something, it's the gain as well. So that's why the common ancestor, well, guess what? When we look in the fossil record, what do we find with these things? That's a good way to distinguish, right? What is a primate and what isn't?
Well, look at...
Go ahead.
Well, Godzilla Freak in the chat says, and the chat's moving quick. We got over 90 people, so I just want to get this in quick. He says these similarities that supposedly distant parts of the tree, even when we look at just primates, are actually an argument for separate ancestry. Exactly. Like their supposed response, just like back to the Y chromosome dissimilarity. You know, maybe this, maybe that. But with no mathematical model, with no predictions, it's pseudoscience. You guys are going to have to do a lot better than that. Anyways, keep going. I just wanted to point out that comment.
Yeah, no, I mean, that was one of the things that evolution made as predictions about common ancestor to human beings. Remember, they thought Neanderthal was a primitive non-species to human being, right? A totally different species. And well, guess what? One of those things that we could look for would be that bone, but they don't have it. So we can go back. How about Denisovan? Do they have that? No, they don't have it either. So we can go, oh, these are in the human line, the lineage. So we know from DNA, but if we didn't have that, if we didn't have the genetics, how would we be able to look in the fossil record? Well, that was easy. See, the first couple species of Lucy were all female, right? The same thing with the new find that we just discovered, this Sediba. Unfortunately, it's female. So we can't find that bone to determine whether or not what category it falls under. Right. So that's why so much storytelling can be done. They literally went to that cave and put a stick of dynamite in there and blew it out so they could get in. So they put an actual bomb in there and exploded. And then the pieces were everywhere. And then they just puzzled it back together, mixing up everything they could to get something. That's the kind of science we're dealing with here. So how about our teeth? Our teeth are very unique, but they try to say that our teeth are actually the same. And but think about how we even use our teeth, not just for eating, by the way, but chimpanzees, primates, they show their teeth for hostility. And some of them show their threat as like a warning or a sign of submission. Why do humans smile at one another? Why do we show our teeth? The exact opposite reason. Exactly the opposite. So it's crazy. We've tried to show Erika a lot of these things in the past. It's like talking to a wall. It's fine. I mean, we're not going to get through. We know now why. You know, she's like on Raw. She'll probably come out as a Satanist later, the same as him. But that's her thing. Like, she likes going to the atheist, you know, anti-theist podcast and pagan podcast and thinking atheist groups. You know, anywhere that she can tell her stories. So we know why she does it now.
Well, Matt, did you want to explain why this visual we made is so important in understanding the different features?
Yeah, these are characteristics and traits that we find in humans only. So when you're looking at these things, you have to say to yourself, like, okay, that's pretty neat and all. What are there, 12 or 13? That's quite a bit, but maybe there's more. Well, there are more. I just threw that together. That was just something that I wanted somebody to have, just to be able to, like, when Erika initially mentioned, there's no way to tell the difference between a primate and us in the fossil record. I was like, really? I can think of a lot of things off the top of my head, and that's what I made up. So are there some missing links or any apes that actually have some of these characteristics? Well, maybe, but they might only have one, maybe two. They're not going to have all of them. So this is what we're looking for. The best thing of all would actually be able to obtain DNA from what we think is a missing link that looks more like a primate. Because if we see that it has a chromosome fusion, it has the same number of chromosomes in us, well, that would be a very good indicator that this is probably some kind of missing link, an intermediary, or that would be great. But unfortunately, we have bones to play with, right? That's all we have. So these characters here, when we see that toe being set off to the side, good indicator that that is not something walking around. It doesn't look like it's very easily designed for that. The design is for climbing trees. There is no doubt. Now, can it walk on its feet? Sure, there's people that can walk on their hands. Gymnasts can walk around for hours on their hands. Doesn't mean that the hand is designed for walking, though. It means you can do it. There's people that are born without legs. They walk on their hands. Great, awesome. Doesn't mean that was designed for that purpose. It just means that they can. You know, they forced monkeys to stand up in circuses and walk. Well, guess what? They adapt lumbar lordosis in their lower spine for bipedalism. Does that mean that their offspring are now going to have bipedalism? Are they ever going to evolve it in their species because they keep being forced to walk around? Well, it's been going on for a very long time since we've discovered monkeys, going all the way back to ancient Egypt. Guess what? They're not walking around yet. So we have to use the observable evidence. And that's why I'm like you. I like the genetic evidence. And if you're going to look for a human being in the fossil record, those are the characteristics that I think really stand out, that make us very, very different. And again, you can see some of these human-like characteristics in very young adolescent primates. So you don't want just a skull cap. You don't want just a forearm bone or a shin bone. That doesn't tell us much, but that's what they take and build entire stories around. The myth, the legend. So,
man, great stuff. Great stuff. So, you know what, Erika, and I understand why she's failing so bad. I mean, think about those that help her. Diaper Dino, you know, man, yeah. I mean, that guy's pretty worthless. Dodgeball Dan, the one trick pony, the one trick, maybe two trick pony. And I mean, who else? Mr. Wilford, who runs from debates with professional YEC geologists. Dr. Stramidas, you know, I did a full response to their interview, and not one of those challenges in a year have been met. But since I made that about a year ago, I am going to do a new and improved, I think, version of that. I'll go through that interview again, line by line, reiterate the challenges that have been dodged. So yeah, I'm going to destroy this nonsense here on the genetic similarities. It'll be dodged. So here's a few papers, not from Young Earth Creationist websites, not that there's anything wrong with that, Mr. Joel Duff, but they can't deal with Young Earth Creationist technical papers or secular technical papers. You notice that? So here's a few papers I highly recommend people check out. Notice this: global analysis of alternative splicing differences between humans and chimpanzees. Surprisingly, 6 to 8% of profiled orthologous exons display pronounced splicing differences in the corresponding tissues from the two species. So even in, okay, so here's the gene expression. Even in similar sequences between humans and chimpanzees, we have differences in gene expression. We have differences when it comes to epigenetics. Okay, we have these differences when it comes to alternative splicing. Notice this: predominant patterns of splicing evolution on human, chimpanzee. Notice this: we analyze the evolution of splicing patterns based on transcriptome data from the 5 tissues of humans, chimpanzees, the rhesus monkeys, and mice. In total, 1,526 exons and exon sets from 1,236 genes showed significant splicing differences among primates. Show us a model of how these differences are. So even in the similar sequences, again, there's still differences. Okay, here's a number of additional papers, guys, that you can screen share. Check these out. I can put them in the description box. These are going to be all available on our new book. More papers on differences in gene expression. So I want to go through this here just to give it more of a layperson explanation of what we're dealing with here. Studies show that gene expression in humans is significantly different from the expression found in chimpanzees, especially in the brain, where one study showed that 90% of the human genes were turned on at significantly higher levels than chimpanzee genes. Exactly what we would expect. Different functions due to separate ancestry. That's why the design diversity model would suggest that the majority of genetic sequences, the majority of DNA elements are there for a purpose and therefore functional. The evolutionists want to say that the genome is no more than 10 to 20% functional max, even though I did a 2-part series with Dr. Fuzz Rana destroying all of their best arguments, okay, that have been put forth by like Dan Stern, Cardinal, and Erika in order to rescue the failed junk DNA paradigm, and that has gone dodged. That has not been challenged. Okay, so I can safely and confidently say the trajectory strongly favors genome-wide functionality, and the arguments that they have put forth, the arguments that Erika put forth in my debates with her, they've been refuted. It's time to counter the data and quit dodging. All right, so especially in the brain. Another study showed the brain DNA sequences of both species did not match evolutionary descent predictions for a common ancestor. Alternative splicing differences. Genes are encoded in pieces by the creator to increase their utility and functionality. The segments that code for protein are called exons, while the intervening regions are called introns. Before being used to make a protein, the messenger RNA copied from a gene is processed by complex cellular machinery that all evolved for no reason, by chance, because, evolution's true. They have no explanation for any of it. Cellular machinery that involves the splicing out of the introns in the RNA and the joining together of the exons. During this process, exons can be omitted, doubled, or even added in from another gene. As a result, a single gene, notice this, a single gene can produce many different variants, like a Swiss Army knife. It's like a multifunctional tool, what we're looking at the molecular level. This whole process is called alternative splicing. How did that evolve? Why did that evolve? And is tightly regulated according to the specific needs of the cell. We got these tightly regulated mechanisms embedded in the genome. The genome is multifunctional, it's nested, it's hierarchical, okay? Multidimensional. How did this all come about? Alternative splicing for a single gene can generate many protein variants depending on the gene. These splice variations fall under very complex regulatory genetic control mechanisms. In fact, the first such research in 2007 showed that alternative splicing differs significantly. Notice this, and I showed the paper earlier, differs significantly between humans and chimps. The authors of the paper state, and we went over that earlier, in such cases of distinct differences, the typical explanation is always rapid evolution, right? Since the split, there's been rapid evolution, and then that's it. Just storytelling and imagination. The researchers go on to say these layers of regulation have evolved rapidly. Wow, yeah, that really gives us an answer. In a 2018 paper using even more advanced technology, okay, throwing a different primate in the mix, the researchers found that in total, 1,526 exons and exon sets from 1,236 genes showed significant splicing differences among primates. We covered that in the paper directly earlier. The uniqueness of human was especially profound in that the increase in isoform inclusion levels, gene variants, showed a twofold acceleration on the human evolutionary lineage when compared with the chimpanzee lineage. Difference after difference, not to mention the Y chromosome dissimilarity we talked about earlier. The mitochondrial DNA is nothing alike compared to the two species. Okay. And this whole 98 to 99% genetic similarity, listen, it doesn't really, whether it's 98% or 88%, okay, there has to be a form of life that we as humans are most similar to. When God created humans, and then the rest of the biological world, by definition, we had to be more similar to something. And it turned out, wow, we're more similar to the chimpanzee than the fish. Okay. But you know what? It's not 98%. It's lower than that. Okay. When you actually consider overall gene content, architecture, size differences, gaps, copy number variations. All right. When you consider it all, it's less than 98%. But at the end of the day, it doesn't really matter. Yeah, we're most similar to the chimpanzee. But it's not because of common ancestry, as we've discussed here. And they're always going to say that these differences have arisen since the split. And we have to assume evolution to prove evolution. We have to assume the split, and we have to account for these differences. I mean, what are they comparing? 2.2 billion DNA letters? Are they considering the non-coding regions? How different are the non-coding regions from the non-coding regions of the chimpanzee? There's all these questions. They do a lot of guesswork. They leave a lot of data out. All right. Once again, such so-called rapid twofold evolution expressed in human uniqueness of alternative splicing for genes previously determined to be highly evolutionarily similar does not support the Darwinian paradigm. Notice this in the brain. Remember she talked about the brain, Matt? Gene expression differences in the brain. One of the first studies undertaken along the lines of reasoning was in 2003, in which 169 different brain genes were found to be expressed in a markedly different manner in human, chimp, and wait a minute, I wanted to show, okay. So if people want to read these papers for themselves, you can pause the video and get them, but I'm going to try and get them into the description box as well. Okay. So Of these genes, 90% were turned on at significantly higher levels in humans compared to chimp. The researchers reported the human brain displays a distinctive pattern of gene expression relative to non-human primates, with higher expression levels for many genes belonging to a wide variety of functional classes. All right. When comparing with different primates, different monkeys, different apes. So again, elevated gene expression levels distinguish human from non-human primate brains. I mean, guys, these are just a couple lines of evidence. Regulatory DNA differences. Okay, here's the paper associated with that. I got it up here. Promoter regions of many neural and nutrition-related genes have experienced positive selection during human evolution. Our results indicate that positive selection has targeted the regulation of many genes known to be involved in neural development and function, both in the brain, notice that, and elsewhere in the nervous system and in nutrition, particularly in glucose metabolism. It's not looking good for ape-to-man evolution, guys. Not only are genes regulated in networks and differently between humans and chimps, so are the non-protein coding sequences in the genome that regulate the genes. Wow. In fact, interesting data have also been produced from the analysis of differences in regulatory sequences that are DNA features that control how genes are expressed. One such study of regulatory DNA sequences are compared the control regions of genes called promoters, and they looked at humans, chimps, various monkey species. Promoters in the regions of DNA that immediately precede the gene and play a large role in controlling its level and rate of expression. Of those examined, 55 human gene promoters were found to be markedly different from those in chimps. Let me read that again. Human gene promoters were found to be markedly different. You see how much Erika leaves out in this video? From those in chimps. Many of these promoter differences were associated with the genes that control nerve cell development. However, many others were connected to genes associated with more basic metabolic activities like carbohydrate metabolism. Differences in regulatory DNA sequence, even minor variation, can result in what? Large effects. How did this all come about? How did this all evolve? It's storytelling, it's guesswork, it's imagination. The epigenome. We've got millions and millions of genetic switches in our genome that are just waiting to be turned on or off via environment. This extra layer of extra complicated information that we know natural selection, right, Matt, acts in the short term. How are we going to preserve life, for tomorrow? It's not worried about getting cancer from 50 years from now. There's no foresight, there's no mind when it comes to evolutionary mechanisms and change, but yet we got the epigenome. How do evolutionary mechanisms like selection and natural selection and mutations build that which requires forward thinking? We have these forward thinking mechanisms in our genome that points us back to the forward thinker. Genetic tags that make chemical changes to genes are known as epigenetic mechanisms. Epigenetic tags regulate DNA sequence. Studies show that epigenetic differences, so even in the epigenome, which makes sense, given the separate ancestry model, they're different. In human and chimpanzee brain genes are far too great to indicate an evolutionary connection, but rather reflect the creature to kind distinctiveness creationists would predict. A study on comparative epigenetics showed orangutans and gorillas, notice this, had more similar patterns to humans than chimpanzees. Again, the Y chromosome between humans and gorillas is more similar than between humans and chimpanzees. We have these other additional genetic patterns that are more similar between humans and gorillas than between humans and chimpanzees. I mean, again, just more lack of uniqueness in the universal phylogenetic tree, more specifically when it comes to the primate and great ape tree. A result completely backward to evolutionary predictions. And the last thing I want to cover, this is newer. The 3D genome is vastly different. Answer this one. Quit dodging. All plant and animal genomes studied so far exhibit complex and distinct three-dimensional structures in their chromosome configurations depending on the type of cell. Example, heart, liver, brain. Given the incredible variability among genome configurations within a single type of creature, let alone that which exists between creatures, human versus chimpanzee. This area of evolutionary comparison has been difficult for secular researchers. So many difficulties for these secular researchers. Isn't that right, Matt? Now, a new study published in Trends in Genetics evaluates research in this emerging field that shows the human 3D genome is what? Distinctly unique in humans, confirming previous research that showed it is as different. Notice this, evolutionists. It is as different compared to chimp as it is to mouse. So I try to get through that as quickly as possible. The papers are there, guys. Check them out. This is right from the secular literature itself. All right. It's time to deal with the data. And it's time for some critical thinking. Rather than blindly believing the conclusions of these authors where it says rapid evolution, engines of evolution. It's like, do you realize that that's not an explanation? Sperm competition. Chimpanzee's the odd man out. Show us a mathematical model. Show us empirical evidence. Give us some predictions. We want evidence, or else it's pseudoscience. Matt, go ahead, brother.
All right. Yeah, I found it funny too that Erika would admit, like, well, there's big differences and there's small differences, but you know, those big differences are because it's been so long. It's been millions of years. But the small differences are because, well, you know, we're still related. What? So anything, it's ad hoc. You could just say, well, of course there's big differences. It's because it's been, you know, millions and millions of years. Well, why is there very few differences over here then? Well, it's because we're cousins. We're super related to one another. It's like, what? These things are just afterthoughts. It's because they didn't expect it, and now they have to come up with a reason for it. That number of the split has changed throughout the time because they keep increasing it because they need a certain amount of things, but they can't go too far because there's not enough, there's genetic problems that come in with that. But here's one for you. If you can go to my document real quick on page 48, you'll see a list of differences that are between chimpanzees or any chimps or any primate and human beings based on
48.
Yeah, exactly. It's all green. You'll see a page that's completely green.
Oh, yeah, I thought you meant in this document. Okay.
Yeah, in my document.
Oh, in this document?
Yeah. It's about halfway down. And what you guys are going to see is this is a secular scientist, by the way. This isn't some young earth creationist that discovered all of these differences. Yeah, just a little bit higher. Perfect. Almost there. And this guy actually came up with his own idea. He looked at this and said, okay, humans, we could be related to them, sure, but there's a problem.
Oh, yeah, here we go.
He thinks we're actually hybrids. Why? Because he can't get rid of the idea that evolution must be true. So for him, he goes, okay, I acknowledge that evolution is true, but there's huge amounts of differences. Too much so for us to only be related to primates. We must be related to pigs and primates because we're a hybrid between the two. So a chimpanzee mated with a pig and produced a human hybrid offspring. And that's he's a geneticist, by the way. And these are his differences that he discovered. Look at all that. Just scroll down. Tons of differences he noticed. And this isn't a young earth creationist coming up with all these differences. He believes in evolution and he sees the huge problems as well. And remember, going back, Erika thinks that our brains are exactly the same as theirs. She mentioned that. Did you know when they tested the brain of a chimpanzee, it ranked so poorly. It ranked below the age of a 2-year-old, right around there. So that means an octopus is smarter than a chimpanzee. It also means that a crow and a key, both of those birds have been tested, and their IQ was higher than a chimpanzee as well. There's also something interesting. It's called an African gray. It's a type of parrot who also doesn't have any close relatives with primates. So their ability to reason was supposedly evolved separately. Imagine that. So we have another example of these things that they predicted that, you know, oh, we're just right behind them. You know what I mean? I'm sorry, they're just right behind us when it comes to intelligence. Well, guess what? That's also been tested. So when they tested human beings on a general IQ test, 96% of all human beings fell within between 30 to 100 on the IQ test. About 68%, the majority of those people actually within 15 points around 100. But a chimpanzee scored 0.1. And right below that, right there, this is the best one of all. They literally thought that the infinite monkey theorem was that a chimp could type Shakespeare. All they needed was enough time and enough monkeys. So they actually did this experiment. Could you imagine that's where your tax dollars went, by the way. So they threw a bunch of monkeys inside of their, their normal habitat to not make anything worse. They just added some more monkeys, but threw a typewriter in there and covered it so it would be safe, and hoped that monkeys would type on the thing. They eventually discovered, like, hey, I can hit these buttons. All they did was spam a bunch of letters. You can see the letters right there. They mostly hit a bunch of G's, and then they held it down until they eventually held a couple S's, and then just smashed it and then crapped all over it and threw it. So that was pretty much their ability to type out anything, as far as that study went. So that was a fun prediction. And but remember, Erika, our brain is the same as theirs. Sure it is. Sure it is.
We're pretty much the same as them in every way. I mean, don't you go to the zoo, Matt, and stare into the eyes of a chimpanzee and think, wow, it's like a mirror.
Yeah, it's pissing into its own mouth. Yeah.
Unbelievable.
Crazy. Yeah. And they're flinging their own fecal matter at one another and pissing in their own mouth. Yeah. That's exactly the same as us, Erika. Same exact way.
Unbelievable. So what's the next part? Let me see where we're at. So we're at 9:03, brother. Did you want to get? I noticed we've got 7:23 here. Just keep going. Just keep going.
Oh my gosh. Yeah, man, I made a lot of notes, didn't I? Jeez. Yeah. Okay. So we get into muscles. She said we have the same muscles as them. They're a little bit stronger than us, but they sacrifice this. Well, think about it. What is muscle tissue? Basically, it's elastic type of tissue, right? It's not very advanced. You can't have a lot of different muscle tissue. So having much diversity in muscle shouldn't be really too expected anyway. But actually, did you know when they lined up muscle tissue, guess what they found, Donnie? Exactly the opposite of us having the similar muscle as our kissing cousin, the chimpanzee. It was more like a monkey. That's right. Again, breaking the phylogeny that they have with us. It actually wasn't very close to gorilla, the pongo, the baboon, or the chimp. Not any species of them either. None of them. That actually goes all the way back to a monkey. And only one species of monkey, too. I forget which one it was. But nonetheless, again, phylogeny messed up. Right? If you're going to say this is our cousin and we have the same muscles as them, okay, back it up. Where's your evidence? And then you search for it. Guess what? Oh, look at that. It's not the same. And we're more same with something else entirely. Brilliant, brilliant, Erika. But I digress. On 7 minutes and 23 seconds, she says that primates can't throw things overhand like we can. Well, Erika, yes, they can. And they've been witnessed doing this. And not only can you see this actually taking place, but they've actually done an experiment, and they actually observed this in Africa with 22 different times. Researchers documented wild chimpanzees on the African savanna fashioning sticks into spears and hunting and using them and throwing them overhand. And here's a video of one here. You don't have to click on it now. Just for the audience later who might want to do this, you can actually click on one using a stick like a spear and using it in an overhand motion to stab through trees and try to get a bunch of ants out of a stump of a log in a tree. So that's pretty funny.
You mean actual observable evidence and not just storytelling or hypotheses with literally zero support? Like actual observable evidence. Wow. Like,
yeah, contrary to what she said. This girl's a primatologist. This is her specialty, by the way. Didn't even bother to look it up. She just was told the story. Oh, humans raise up our arms because we left the trees, and there's no reason to raise our arm ups. That's what she said. There's no reason for humans to raise your arms up. Oh, really? There's no reason to wash your hair or comb it. There's no reason you would actually need to raise your arms up to put a shirt on or to reach something out of a cupboard. You should try to live with 24 hours without raising your arm up sometime. That means you better go to the cupboard and put all your food down because you can't reach up to grab it, by the way. So, I mean, think about that leap of logic where we don't need to raise our arms up anymore because we don't climb up trees. That's just absolutely insane.
Well, that reminds me too, Matt. What's their best explanation for the hyoid bone, the variant that humans have that actually allows for speech and language. Primates have the bone, but not the same version, different version. You know, they like to play semantics, right? Well, I mean, they still have a bone. Well, it's a different version, guys.
Yeah.
There's no speech and language associated. So, you know, those massive gaps, you know, in anatomy and so on and so forth. Yeah. What's their story on that one?
Well, they go, okay, well, of course they have the bone, but because they need to make sounds, right? They need to have some kind of a noise to make to warn others when there's an impending danger, mating call, whatever the reason, there's going to be something there to make a sound, right? But ours is created, designed for speech. Theirs is not. So they go, it's okay, because, you know, they didn't need to do this. There's no need for that in their group of pattern. It's kind of like, okay, well then wait a minute. So there was a need for us, but not for them, even though we are related. Remember that. So why would there not be a need for them and a need for us when the exact same explanation is used for contradictory explanations? It just makes no sense. I mean, think about that mental gymnastics for just a minute, saying, well, they don't need that, but we did. Well, why? I mean, that doesn't make any sense. Of course they would need it. If we needed it, they would need it. So, I mean, again, just more story. It doesn't explain anything. Just saying we needed it, what does that even mean? That's just semantics. Again, there's no evidence for any of this. They can just say it and everyone believes it because you don't question evolution. Imagine you've got a test coming up and you're in secular school and you're like, oh, this isn't true. You can't write that. You better write what's exactly in that book. You're not supposed to question it. And that's not what science is about. Science is about questioning it. That's why all of the things that overturn the major paradigms come from outside, not with inside. You can't think differently if you've been indoctrinated and you're all thinking the same and you never question the paradigm. You're supposed to question it. And you want to do these things. If you believe in evolution and you actually want to see how dogmatic they actually are, go ahead. By all means, go test them. Pretend you're a young earth creationist for a day. Watch how you're treated. Why don't you write up a scientific paper, make sure it's 100% legitimate, and then send it to peer review. And all I want you to do is put in the title creation. Anywhere. Doesn't really matter. Young earth creation doesn't matter. Make sure that they know that it's a young earth creations thing. They won't read a single page. No matter how absolutely perfect the paper is written, they won't even look at it. So what does that tell you? They're not interested in actual good science. They've already made up their mind what's true and what's going to be looked at and what's going to be peer reviewed, published, and passed. That's anti-science. So let's move on because I'm going off on a tangent there. My bad.
No, you're doing good. It's giving my voice a break. So keep it up, brother. I know. I think you were next going to get into the some more genetic differences that kind of I was talking about, or wherever you were going. Yeah, go ahead, and I'll just, as you're talking, I'll screen share on some papers and stuff that kind of support what you're going to say.
Okay. Unfortunately, at the 8-minute mark, I replied to something that I don't know what that is right now because all I wrote was, "Oh, so we can do it because our ancestors did." And then I wrote, so basically, well, that begs the question: why can't we do things our ancestors could do? It far outweighs the things that we can do. So again, it comes back down to that circular reasoning, where storytelling, right? You just jump right back into it. It's like, oh well. We don't need to do that anymore, or they can do it because they're better at it and stronger at it. It's just more nonsense. I get into that as well. And then at 8 minutes and 5 seconds, basically she knows this is a lie. How do I know? Because we talked about this and debated young earth creation constantly for the few years. And what I'm talking about is that genetic similarity that you mentioned earlier, where there's a difference of around 85%, which is 300 to 400 million DNA letters. Now, what those differences really are is she's trying to make that number as high as possible because she only wants to look at the protein coding genes, right? So therefore, they're the highest functioning capacity in the genome. That's for sure, because they're doing that. So what they did is they excluded anything that really wasn't lining up. So when they did things that didn't line up, no matter what their function was, they didn't count them. That was 25% of the human genome and 18% of the chimpanzee genome. They just threw it away. And that was secular science that figured that out. I put the link to that as a video that you guys can watch later. It's only about 2 to 3 minutes, and you can watch them do it. And then at 8 minutes and 11 seconds, we're talking about the Y chromosome is more similar between us and gorillas than it is to chimps. But since we already discussed that, we will move on. And then at 8:22, she talks about ERVs. And then again, it's starting with the idea that these dead viruses are viruses that aren't alive, so I shouldn't even say dead. These viruses have bombarded the system over eons of time, and then eventually they stopped being viruses, and they accumulated so much that they eventually just poof, they magically evolved these awesome beneficial things that we can't live without, and they transcribe things. They help with the placental development, and then all of a sudden they get mutations, and now they're back to being horrible again for us. That makes sense. And then during that process, humans just magically evolved our own, by the way. Since humans have only been around for a little while, we just magically produced HERVKs, which are human versions, and primates and chimpanzees also have their own, which are completely unique to them, that also function very uniquely only to them. So again, complete separate ancestry examples is what we see, but yet they've convoluted it and made that evidence for human evolution somehow, because it's nonsense. But and then at 8 minutes and 30 seconds, she just admitted to special creation without even realizing it. That was kind of right before you ended the video. I found that pretty funny. And then did you stop it at 9 minutes?
Let me see here. Yeah, exactly 9 minutes. 9 minutes and 3 seconds.
All right, let's play it some more then.
So to back up what you're saying, and fantastic job, brother. This is too much fun. We could do this all night, I'm sure. Again, okay, we've had so many debates with these guys and others. I debated a biologist on Tom Jump's channel like 2 years ago now. And I specifically asked him, show me a paper. And I've asked all of them. RJ Downard, I've debated 4 times. Erika 3 times. Give me a paper. Show me empirical evidence of non-functional DNA elements like endogenous retroviruses, some of what they refer to as or assume are pseudogenes, ALU sequences, other classes of retrotransposons, whatever. Show me this co-option. Because you know what, just saying co-option or engines of evolution, that's mere uninformative gloss. It's storytelling devoid of any real evidence. I just debated Luca Medugno for a few hours, formal debate the other night. And one of his main lines of evidence was ERVs. He couldn't show the paper. It was a great debate. I mean, no, nothing against him. I mean, nobody can show us this. Okay. And just talking about viruses in general, just viruses. Okay. When evolutionists hear the word virus, they seem to assume something that is bad. Well, I constantly point out, okay, that we have more viruses in and on our body. As a matter of fact, we have more bacteria in and on our body than we do cells. And we have over 10 trillion cells. Why aren't we all dead? That's because most viruses are good. The great majority of viruses are good. They help regulate. They help with the ecosystem. Okay, notice this from BBC, why the world needs viruses to function. Remember, it's all about function. The vast majority of viruses are not pathogenic to humans, and many play integral roles in propping up ecosystems. Others maintain the health of individual organisms, everything from fungi and plants to insects and humans. We live in a balance, in a perfect equilibrium. I think we'd be done without viruses. This is a virologist, Susanna Lopez, saying this. Okay, you wouldn't want to live in a world without viruses and bacteria. Now, specifically, endogenous retrovirus. What's this? How do retroviruses become endogenous? Human endogenous retroviruses, HERVs, represent footprints. So you can notice in this article here, technical article, the built-in evolutionary assumptions, right? Represent footprints of previous retroviral infection and have been termed fossil viruses. See, if the evolutionary, if universal common descent is true, ape-to-man evolution, more specifically, then we would predict the genome is full of evolutionary leftovers, genomic fossils, ancient remnants of past viral infections, like we see here, is being propped up as evolution. The design diversity hypothesis would suggest that we should see function. We should see DNA elements that are there for a reason, that are there for a purpose, that are there to sustain healthy life processes in the cell. So where evolutionists see shared genomic fossils or shared genetic mistakes, they are assuming that that's what they are. When it comes specifically to endogenous retroviruses, the real question is, are these really the ancient remnants of past viral infections over millions and millions of years? Or are they created units of DNA function? Evolutionists have never predicted function. They've always assumed they are just fossils. They are junk, not there for a purpose. But yet we see more and more data that comes out suggesting that a massive number of them are functional. And we're finding these functions by accident because they're not assuming function. They're assuming junk. We're finding them by accident. So imagine if we were to look for them with intention, right? Because we've only functionally tested very little of the human genome, including these retroviral-like elements. Okay, notice this. Switching sides, how endogenous retroviruses protect us from viral infections. Isn't that amazing? That God front-loaded the genomes of living organisms with not only pre-existing genetic diversity, right? Pre-existing heterozygosity, where we've got millions and millions of DNA differences in chromosome pairs. Right? God didn't say be fruitful and clone yourselves. He said be fruitful and multiply. That wouldn't make sense if it were meant to be carried out through cloning. So of course we should expect pre-existing genetic variation. Well, it also turns out that God front-loaded the bare gnomes, you could say, with variation-inducing genetic elements, with DNA elements that help protect us from viral infections, help in the immune system, help for a number of things. Long disregarded as junk DNA or genomic dark matter, endogenous retroviruses. And remember, the ERV didn't name itself ERV. Okay? Because the evidence suggests that these are functional units of DNA, okay, they should probably have a different name, because when you hear endogenous retrovirus, you automatically assume common ancestry. Okay, these are functional DNA units. Here's the thing. We know so little of the genetic language, the DNA language. If I were to, and I use this analogy frequently, I got it from Dr. Nathaniel Jeanson, it makes a lot of sense. If I were to go to Russia, I speak no Russian. If I were to go to Russia, okay, to be a proofreader, that's not going to make any sense. I don't speak Russian. I don't know how to read Russian. I can't write in Russian. So how am I going to be able to tell what is a mistake and what isn't? And that's how it is when you're looking at the genetics, because it's science fiction on a molecular level. Just 40 years ago, they had this mindset, one gene, one protein, one function. That's been overturned. Okay. We've discovered protein multifunctionality, protein moonlighting. I got papers on that in here. We understand that third position codon variation, we frequently discuss how it's not just there to tolerate error, it's functional in information flow as well. We see functionality on so many levels in the genome. Okay, so notice this. Long disregarded as junk DNA or genomic dark matter, endogenous retroviruses have turned out to represent important components of the antiviral immune system. So where evolutionists look to the genome and say, you know, this is a mistake, this is a fossil. No, it's premature. It's premature to make that conclusion, because for one, I've got a dozen papers here showing how important these so-called pseudogenes are. It's premature in the same way that it would be premature to go to Russia as a proofreader and say that's a mistake. I don't know for sure. Okay. These remnants of once infectious retroviruses, there's the assumption, not only regulate cellular immune activation, but may even directly target invading viral pathogens. Okay. If your model's better, Gutsick Gibbon, show us a paper on how these important functional roles came about. Because guess what? A viral insertion is more likely to disrupt genetic functionality and genetic information than make it better. Okay, if I had a painting here and I put a blindfold on and I started applying random brush strokes to it, I'm more likely to ruin the painting, not make it better. But apparently, these viral infections eventually adopted these important functional roles in the embryo. I mean, It's ridiculous. Not only regulate cellular immune activation, but may even directly target invading viral pathogens. One focus will be on recent advances in the role of ERVs as regulators of antiviral gene expression. Speed of sound. The other day, he's like, Standing for Truth. He keeps asking this silly question. I mean, we can't show him this. This happened millions of years ago. It's like they don't even see the built-in assumptions, right? It just happened. It's too long ago and far away. Then it's a fairy tale. Speed of sound. It's not science. Okay, you can believe that. You can believe in co-option, and I say believe with a capital B. You can imagine. It's not science. Junk, no longer junk. ERVs are integral and important components of immune responses. Right here, this sums up Erika's argument. ERVs have long been a go-to argument against ID from those who believe that our genomes are full of undesigned junk. An outgrowth of this view is that ERVs have no functional importance. And that shared, this is where they go to common ancestry, and that shared similar ERV sequences in similar genomic locations across different species. Yeah, we understand there are shared endogenous retroviral-like elements between humans and chimpanzees. That's why we would predict common design and therefore function. And that's what we find is function. End of story. You can say co-option all day. Without empirical evidence, it doesn't matter. And it's not just one or two ERVs that are functional. It's massive amounts that are functional. Regulating and initiating transcription, functional in the embryo, necessary functions. After goes this way of thinking, ERVs were clearly not put there for any purpose. Notice this. If this paper, this is commenting on the paper here that we were talking about. However, then ERVs frequently have important immune functions and they should not be presumed to be junk DNA. This defeats both the junk ERV argument against the design of the genome. It also challenges those who want to use the supposed junk status of ERVs as an argument for common ancestry. Well, we never predicted that it would all be junk. Show us where you predicted function. Oh, that's right. You can't because you never did. After all, if ERVs have functions, then shared ERV sequences, notice this, because I know it's usually in one ear and out the other with the evolutionists, then shared ERV sequences in similar locations across genomes of different species may reflect functional requirements rather than mere common ancestry. End of story. Quit using ERVs, because guess what? Every time an evolutionist uses ERVs in a debate with me, they get exposed because ERVs are actually confirmation of design diversity, LTR. The long terminal repeat element of an ERV has the capacity to exert regulatory influence as both a promoter and enhancer of cellular genes. And we can get into the whole model pertaining to, we've written articles on it, so for sake of time, I'm not going to, but there's a whole creationist model on it. But it is the function that's key. So here's some papers on pseudogenes. Okay. Here's a paper here. Recent results are challenging this monitor. You got people like William Lane Craig who know nothing about the science of ancestry. Oh, I'm a theistic evolution. Evolutionists. Humans and chimpanzees, they're related. They have pseudogenes. Shared pseudogenes. It's like way to be behind on the times there, William Lane Craig. Pseudogenes. Notice this. Far from being silent relics, many pseudogenes are transcribed into RNA, some exhibiting a tissue-specific pattern of activation. Some pseudogenes appear to harbor the potential to regulate, notice this, regulate their protein coding cousins. Makes sense. You got the protein coding regions of the genome, the non-protein coding regions of the genome. They're working together for the function of the organism. It's like a play. You got a play. You got all the actors and actresses on screen. That's not all that's going on. Behind the scenes, you have a lot going on. You have the writer, the director, the producer, the person running the lights, the sound. You don't necessarily see those people, though, while you're watching the play. But guess what? They're necessary. Just like DNA elements like pseudogenes, ERVs, ALU sequences are necessary. Notice this. More, there's 5 papers right there. It's not just 1 or 2. Okay, let's leave no stone unturned. Look at this research paper. Far from being junk DNA, the pervasive retrotransposons that populate the genome have a what? A powerful capacity to influence genes and chromatin. But don't you see, Donny and Matt? There's a thing called co-option, pseudoscience, mere uninformative gloss. We want the empirical evidence, not storytelling, okay? A new study demonstrates how the transcription, notice this, Matt, of one such element, HERVH, can modify the higher order 3D structure of chromatin during early primate development. I mean, co-option, guys, co-option. And we could go on and on and on and on, right? Functional DNA elements. Look at this. The three-dimensional organization of chromosomes enables long-range interactions between enhancers and promoters that are critical for building complex gene regulatory networks in multicellular species. This paper here, transcriptionally active HERVH retrotransposons demarcate topologically associated domains in human pluripotent stem cells. A lot of big words there. But point is, function after function, paper after paper. Right here, here's what I wanted to. We report the existence of 51,197 ERV-derived promoter sequences that what? Initiate transcription within the human genome. Again, it's not just one or two, okay? I've seen this argument used by, I think it was Barry Despero. How is it that so many inactive copies of KORV survive in the koala genome? Around 8% or more of the human genome is made of retroviruses. If the KORV is retained in the koala genome as junk DNA, it would most likely be removed from the genome. Remember, if most of the genome really is junk and this activity, right, ENCODE suggested that over 60 to 80% of the genome is active, if that's just spurious, that wouldn't make any sense because it's wasteful of energy and resources for the cell. Natural selection would have just ridded the genome of all of this junk and evolutionary leftovers. It would cost the cell too much energy and material to keep the junk DNA intact for an indefinite length of time. This would be like printing a book with extra pages of gibberish at the end over and over again. So apparently, through evolutionary processes like natural selection and mutations, okay, we can go from a single-celled like ancestor to a multicellular organism, to a fish, to an amphibian, to a reptile, to a mammal, to a man. Okay, we can go from a single-celled like ancestor to a whale, a single-celled like ancestor to a man, indirectly, of course, over lots of time. But selection, can't remove the genome of all of this junk. Give me a break. It's like they give natural selection limitless powers, except here where it contradicts their model, like, well, selection just kept it around, just replicated all this junk because, who knows? It would be superfluous to keep junk DNA in the genome for such a long period of time without eliminating it. It is much more likely that ERVs such as KORV already had some function in the genome to begin with. And the last one here was, for sake of time, I've done full shows on the details of the creation model when it comes to these elements. But at the end of the day, they can't provide any empirical evidence for co-option. So, I mean, it's end of story. End of story. The retroviral promoters in the human genome, antiviral immunity, intronic ALUs, influence alternative splicing, immune response. I mean, we could talk all day on it. So, Matt, over to you, brother. I know that was a mouthful, but time to put that one to bed, eh?
Yeah, got to finish off the ERVs. I mean, they're basically refuted with two logical things. Why would the body supply junk DNA, which ERVs are? Why would they supply with them functional? ATP. Why would the body utilize and give it energy if it doesn't have at least some sort of function? It's very wasteful, and ATP isn't wasteful. Your body doesn't want to waste energy where it doesn't need to. You're burning. Calories are very important, especially for the brain. So you're going to tell me that the body is now going to utilize and give the energy to something that has zero function, zero purpose. That makes no sense. Another good one is that, how about this? Endogenous retroviruses, there are some of them that actually attack viruses. Think about that for a minute. It's a virus that evolved to kill virus to itself and others like it. Think about that one. So again, logically, you have to wonder, okay, we got bombarded with a virus. It became useless. And then all of a sudden, it gained a function to now kill its own kind and itself. Not the best type of theory going on there. They didn't logically think that one through, I don't think. So, yeah, you pretty much covered everything I wanted to. I will check additional timestamps, but I think we're ready to move on. I'll wait for you to come back. I assume full screening me means you're gone. So 9:03, you will see how desperate scientists are to connect any and all dots to common ancestry. I don't know where we're at.
All right, yeah, we can move on.
Yeah, we're ready.
And just for people who downplay junk DNA and the DNA function that we're discovering, confirmation of design diversity. Notice this slide. Just four things, okay? 4 points. The human genome is a complete storehouse of important information, and this negates the concept of junk DNA. Protein coding genes are largely a basic set of instructions within a complex of large repertoire of regulatory DNA sequence. Many more genes exist compared to protein coding genes that code for functional RNA molecules that are not used to make proteins but do other jobs in the cell. DNA to RNA to protein. Except RNA molecules are necessary for a million different things. Okay, so it's not always, well, the end stage functional protein, that's what's functional. It's like there's so much more than that. Only 2% of the genome codes for protein, and the rest is like a massive control panel, okay, controlling things, turning genes on and off, functional in development. We have all of these different developmental windows. Okay, where you have certain genes that are active and then redistributed somewhere else. And you have a gene over here that's controlling a gene over here. And it's, like I said, it's science fiction on the molecular level. A vast number of regulatory switches and control features exist in the human genome that regulates its functions. And we have dozens and dozens of papers that demonstrate this. So yeah, I mean, end of story. I'm sorry. It's just over for the evolutionists. So, all right, let's go to the next part, brother. So we got 30 more minutes, guys. Like I said, we're going to do a series. So we're getting through as much as we can in 3 hours. And Matt, I can't believe it's been 2.5 hours. Like time flies by when you're refuting evolutionists, right?
Yeah, it does. It's easy. It's fun.
It is. It's the same things over and over again. They refuse correction. So, all right, let me know if the sound's coming through.
Gill? What would you call that?
Pharyngeal gill slits. So it's fascinating to think about, but much of our face, including our inner ear bones, right? So your malleus, your incus, and your stapes, that allow you to hear the way that you do. In utero, they come from these primitive structures that in a fetus, in an embryo of the same age in fish, become their gill arches, right? So it's ontogeny recapitulating evolution. Right? In the same way, and I think this is very fascinating too, obviously we have tails in the womb. And when you don't properly terminate that tail, it can stick around and people can be born with tails. In dolphins and whales, so cetaceans, for a very brief period, I think it's about 2 weeks, they have little hind limb buds that grow and then they terminate and they reabsorb back into the body. Why would they do that if they didn't have an ancestor that was terrestrial? And in the fossil record, there's a critter called Indohyus, who's this little hoof mammal that ran along the coastlines where we find it in these ancient coastlines. It's got this little structure in its ear called the involucrum. And every modern whale and dolphin has it, and no other animal we know of does. This is a unique structure. It's been carried through the lineage of these creatures in the same way that we carry our ape heirlooms and our monkey heirlooms and our Omamiyad heirlooms all the way down to present. We all carry the what Darwin says, the stamp of our lowly origin. But I think it's a lot more incredible than that.
You engage intelligent designers, creationists. I mean, they're not always the same thing, but I understand how they have maneuvered away from creationism with a capital C into ID to try to remain relevant, teach the controversies kind of stuff. Do you, I think of Stephen Jay Gould, who said that religion and science are non-overlapping magisteria. I mean, I don't know, can religion and science...
Might be a good place to start, brother.
Yeah, absolutely.
You get the honors.
Okay.
If you need me to share a screen, let me know.
No, it's all right. So the first thing she started out with, she showed a picture of the gill slit in the ear, right? And she was like, "This is the pharyngeal gill slit. This shows that we're related to fish." And what's interesting about that is actually that's been a study. And in 1998, Manley and Capici did a study, and they actually came to the conclusion that they do not contain even partially developing gill slits, and that they have no respiratory function at all. In fish, these structures quite literally slit from the opening to allow water in and out of the internal gills that remove oxygen from the water. In human embryos, however, the phalangeal pouches do not appear to be old structures, which have been reworked into new structures. They do not develop into homologous structures such as lungs. Instead, their developmental fate of these locations are included widely in structures that help become part of the face, the bones associated with the ear, and the facial expressions and muscles of the thymus, thyroid, and parathyroid glands of the throat. So think about that. Here she is showing something which is a deformity in a single person's ear that didn't close, and now using that as evidence as though we're related to fish, when nothing could be further from the truth. This is, I mean, see how little research she did on it? It actually has a function, and and it has nothing to do with breathing, or it has nothing to do with being a gill slit at all. But what's the answer? Always to her, it's a co-option. It's an example of how we retained it throughout the years, and it's retained in human beings from co-option. Just more ridiculous rescue devices, which I think are just absurd, by the way. But so basically, they found a single person named Molly who had that small hole there, which is the deformity that's found in the ear, and to say that we're related to the fish. But go ahead and look up primates that have it. Go ahead, look up animals in our supposed lineage. You won't find any. Why is it? So I mean, it missed all the pongos, the gorillas, the orangutan, or the chimpanzee line. Just landed on us, and it's so rare that it only happens when a rare deformity occurs, and that proves now that we have gill slits from being in the womb, which is an aquatic environment, by the way. But still funny that it has nothing to do with it whatsoever. So see what I mean? Just quickly looking something up, just very, very little bit, just exposes instantly what she's saying to be true. But the audience, they're never going to check on what she has to say. They're just sitting there going, ooh, wow, ah. And even other people that might be like not knowing anything are probably sitting there like, wow, that is really good evidence, when it's so easily refuted. I mean, I put together this 40-page document in like a day while I was doing other things. I mean, come on, it's ridiculous. But I mean, think about why are their traits shared at all? Because every programmer uses a source code for a program. It's a language that we would see looking at in the biological life if there was a creator that created life. And that is exactly what we see. So the real question would be, for any critic out there, why would a programmer use a different source code for every piece of software rather than use the same framework and language for each application? I mean, logically, come on.
Right.
You would know not to do that. You would reuse your program. You just designed the thing. So of course you're going to put it in everything. So, all right, over to you. I'll calm down.
That was good. Yeah. So right here, for example, you got to love how, there's a picture of the bone that is there for a purpose, for function. I mean, this whole argument pertaining to vestigial organs and remnants of our past common ancestors. No, these things have function. I mean, notice this: whale reproduction. It's all in the hips. New study turns a long accepted evolutionary assumption on its head, finding that the whale pelvic bones play a key role in mating. I mean, Cretaceous are not making this stuff up. Indohyus. She mentioned that. Pakicetus. The first walking whale to be discovered was classified as a cetacean because it possessed an involucrum. Yet it turns out that Indohyus also possessed an involucrum. But it is not considered a cetacean. Funny that. Instead, it is classified in the order of mammals that includes pigs, hippopotamuses, giraffes, antelopes, sheep, and cattle. Thiessen and his colleagues who described Indohyus wrote in 2007, until now, the involucrum was the only character, notice this, Matt, occurring in all fossil and recent cetaceans, but in no other mammals. Identification of the involucrum in Indohyus calls into question what it is to be a cetacean. Notice how they just force fit it in, right? It never question the actual theory, just force fit any new find, regardless of how contradictory it is, into the story. It requires either that the concept of cetacea be expanded to include Indohyus, or that the involucrum cease to characterize cetaceans. I guess, some decided to just expand, apparently. Expand the concept of cetacea. The authors argued for the latter. that the involucrum should no longer be used to characterize cetaceans. But apparently, I mean, just irrefutable evidence that, some tiny little wolf-like creature evolved into a blue whale. I mean, just imagine, right? In other words, the involucrum is a diagnostic of cetaceans, except when it isn't. Just like earlier with convergent evolution and homology, or homology and homoplasy. Right? Similarity is proof of common ancestry, except when it's not, it's proof of convergent evolution. It's a comedy show. Sloppy Saint comedy show. He shouldn't feel so too bad, because we have evolution that says humans and banana plants are related. It doesn't get more, comedy show than that. So let's see. Why should we call Pakicetus a cetacean? Why not just call it what it was, a land mammal? And why should we call Ambulocetus, Myocetus, Cuchicetus, and Rhodocetus cetaceans? Why not just call them what they were? Amphibious mammals that spent part of their lives on land and part of their lives in the water. It's fossil evidence. I've got a whole presentation here on whale evolution, but it's such a joke. Again, it's based on, artistic license, based on storytelling interpretations, faulty interpretations of the data. But one thing I wanted to address here, actually something from the beginning, this is funny, when it comes to the classification systematics, you can literally get a PhD. Just research a little bit. Just type in, how to classify automobiles. There's enough information and data there where you can get a PhD in that. I'm telling you, you can put a lot of time, energy, effort, and money into classifying anything. You could be a master at classifying modes of transportations. Okay. Automobiles can be classified in several ways based on their nature, behavior, load capacity, design, and more. And it proves relationship, right? I have mentioned below some of the most important categorization of automobile based on the purpose of the vehicle, load capacity, fuel use, number of wheels used, suspension system. So many things. The point is classification systematics doesn't prove anything. Okay. So even if there were these just amazing shared embryological patterns when it comes to development, who cares? Who cares? Again, the design world, what do we know? The logic extends even further into the manufacturing process. For example, if you visited the assembly plants of these automakers, you'd probably find a temporal stage in the manufacturing process that is shared. Despite the obvious differences at the final product level among Hondas, Chevrolets, and Mercedes, basic rules of efficiency and function result in similar stages of manufacturing. Whales and humans are both mammals, believe it or not. Is it a huge surprise that there may or may not be some, similarities in the early stages of development? In fact, you'd probably even find shared elements in the blueprints for each of these cars. Why? Since the end products have similarities, the blueprints will as well, of necessity, have them as well. Okay? The final creature, just like the final product, is where we see the biggest differences. Yeah, there's probably going to be a lot of shared elements in the blueprint, in the stages of development. In the same way, there's similarities in the different stages of manufacturing, but the final products are where we find the biggest differences. So again, whale evolution, shared patterns in embryological development, not convincing, not impressive. Matt, what are your thoughts, brother?
Yeah, it really comes down to mutations. Their entire theory really revolves around mutations, no matter how you want to think about it, no matter what. My chair just went down on me. But you gotta look at the mutations and what they're supposed to do. These mutations are supposed to build new, better, and good information to take these things. Now you can say, well, no, it doesn't have to do anything. Well, according to the textbook, it does. Because you're going to need a lot more genes than the 1,500 or so, whatever that original bacteria-like species was, to create all the genetic diversity that we see in the world today. And what do we see when we take a region of the body, like even the PAX6 gene for the eye, and we decide to throw a mutation in there? Well, guess what? We mess the vision up. We don't get a new type of eye out of it. We hinder the vision that is already pre-existing. So no matter if you want to just throw in minimal point mutations, guess what? You're still going to mess it up. So that's the problem. Most of the changes that we're seeing are epigenetic anyway. But mutations are what kill evolution, which is hilarious to me because it's mutations that should be the evidence for evolution. But you can always refute evolution very easily with mutations because you can ask an evolutionist at any point in time, make a prediction with mutations. They can't do it. Then you can say, okay, maybe you can do something really simple for me then. Can you pick an animal? I don't care what it is. What's your favorite animal?
A lion.
A lion. What's a lion going to look like in 10,000 years from now through speciation? Well, maybe the lion might still be around. Maybe it will have gone through adaptations. Can you tell me what that lion will be in just 10,000 years, by the way? We're not talking 100,000. I give you a low number. Of course not. Nobody can. You know why? Because evolution can do anything. So they just admit right there that there's no predictive power in it because evolution can do anything. So if it can do anything and it has no predictive power, then it's not even a theory. And you can ask that to anybody that believes in evolution. Say, where are humans going? What are we going to do? Are we going to speciate? What about your dog? Where's that going? They can't tell you anything because evolution's blind. Like you said, it's blind. How can it guess the future? Well, it can't. Natural selection can't see it. We can't see it. So if it can't be predicted, it's not a theory. It's gone. The only people making predictions on mutations, ironically enough, are us, the young earth creationists of all people. And evolution isn't. And their theory is based on mutation. Absolutely hilarious.
That's a great point, brother. And that, I think, is going to bring us to the next stage, which we could pretty much talk for hours on, is how do we set a boundary? Where do we draw a line in ancestry? So I believe that she's coming up to that part. And maybe that's where we'll go. That's where we will refute her on. And maybe that's where we'll stop for the night. So let's see. Let's go back to, so as everybody in the audience can tell, we've got unlimited information here, which is why we need to probably break this up into a couple parts. So, okay, let's see. I believe it's coming up here. 11 minutes. See, here's the thing, Matt. When you're saying more things wrong in one sentence than words that are in that sentence, it's going to take hours and hours to refute, right?
Oh,
just so many errors.
So many. You can't be like every single second is another timestamp. It's crazy.
Good job, security.
Yeah.
And play together from your perspective?
There are folks that disagree with me on this. I know many excellent scientists who are religious.
Francis Collins, right? The Human Genome Project, who was a proponent of evolution.
Oh, yes. And in the Kitzmiller versus Dover trial, if memory serves, or at least a consultant for it. A great many of our scientists, from paleontologists to geneticists to evolutionary biologists, are people of faith. I don't think there necessarily has to be a clash there. I think the danger shows up when you go back far enough in time, and eventually there is going to be a concession, at least on the side of the religious individual, who's going to say, okay, well, it had to be fine-tuned. Either the conditions for life to emerge in an abiogenetic fashion, or a finger touching on the water, right, to spark life in the first place, guided evolution, perhaps. And from my perspective as someone who is involved with science, so long as you accept the principles and the methodologies of science, and you do good science yourself, I frankly don't care where you think the motivation comes from.
Yeah, right.
I will be considerably more suspicious of folks who are quite open about that, just because at some level they're starting with the conclusion first and working backwards, and that's a dangerous game to play. So I think there can be excellent religious scientists. I know many of them myself, but I hope that they are particularly wary and on their guard in order to keep these megasteria, as you say, from overlapping and one from impeding the other. And if they're religious, we know which one's going to win out.
So you're engaged with a creationist, and come on, which one really cooks your noodle? Which argument or proof do you hear and part of you dies inside? Or maybe there's more than one.
I mean, for me, so because I do human evolution, right, the biggest one that gets me is there are no transitional fossils. That's the one that kills me. And they'll look at the hominins, the 21 plus hominins that we have, and they'll say, well, they can all be categorized as either human or ape, which is hysterical because that's like saying that all of a dog lineage can be categorized as dog or canine, right? It's like they are canines in the same way that we are apes. But the lineage of humans, of hominins, going backwards in time, is so ridiculously smooth that on my trip to the Creation Museum recently, I noticed that they just frankly omitted several of them because they couldn't fit them into a box. I'll show you the Casidiba and Homo habilis and Homo rudolfensis, 3 hominins that have an intermediate brain case size between a human and this ancient common ancestor between humans and chimps, but are definitively bipedal. So it's a creature that's walking upright on 2 feet. This bipedality emerges very early with Ardipithecus ramidus. And then they've got this intermediate brain case size of approximately 500 to 700 cubic centimeters. So what do you do with that if you're a creationist? How do you cope with God creating an organism that is a perfect intermediate, as perfect as someone who is interested in evolutionary biology and paleoanthropology could ever ask for? How do you cope with that? Where does it fall? And as I've mentioned before here at the forum, the response to this is generally either ignoring it or something just outrageous, like saying, well, those transitional species are a mix of human and ape bones, actually, and they just look really transitional. Okay, how about the transitional aspects of the skull, where it's moderately prognathic, like a chimp with a little bit of a muzzle, and it's got a medium brain case size? That's not like a mix. Oh, you can't mix two craniums together, right? And that's to say nothing of some of the specimens that are in articulation, where we'll find, they'll be like, well, the hands are too human, so those are from the human, but the arm is actually from an ape because it's very primitive. Oh, interesting. How come they articulate together like pieces of a jigsaw puzzle? Why were they found in articulation as if you would find a modern forensic scene, a skeleton that's still connected with its bits, effectively? And then at that point, they'll usually just change the subject.
The Creation Museum, I mean, you made it all the way through without putting your head through one of the dinosaur displays?
Yeah, because she dodged, duck, dip, dive, and weaved her way through every single actual creation scientist there.
Yeah. We got a PhD scientist over here who can answer your questions. No, we'll just walk this way.
Yeah,
so unfortunately, the part where, draw the line in ancestry, guess it wasn't there, closer to the end. So there's a lot there. There's a lot there, especially on low quality, low confidence science, again, bones found in the dirt. So apparently you're only going to be taken seriously in the scientific community if you believe, capital B, that banana plants and whales are related. Then you'll be taken seriously. Dr. Francis Collins, he's so behind the times. I mean, his best lines of arguments were what? Shared genetic mistakes, pseudogenes, overturned, necessary to sustain healthy life processes in the cell. This argument pertaining to, ancient repetitive elements that are shared across various forms of life, including ERVs, retrotransposons. We've already demolished that. Nested hierarchical patterns in DNA, anatomy, morphology. Nope, we've already destroyed that. Okay, so the very best arguments that Francis Collins has used have mostly had to do with junk DNA, and yet the whole entire junk DNA paradigm has been overturned. We've already dealt with that. And so I guess we'll kind of just move into the low quality data. And Matt, I'll let you start. Go ahead, brother.
Sure. I did notice a super chat come in, though, if you wanted to answer it real quick. Yeah, perfect. Following, how did a wolf give birth to a non-wolf? And what's wrong with saying that a chihuahua is more related to a rat in creationism than a human to a hominid? I think I got that. A wolf. Well, we gave the term wolf, and then we also came up with the term dog because we invented breeds. So a wolf gave birth to something that was more similar, like to a wolf, but we got a hold of them and we realized that there's a lot of genetics in there that we can manipulate around, right? It was pretty heterozygous. It had a lot of potential in it for species. So we took that and we started breeding them, and now we have the most diverse dog breeds that we can get. But look at all the diversity in the dogs, right? Looks like there's quite a lot, but you can still tell there's that wolf heirloom that's still there that you can get from that because of speciation. We can look around and see all the diversity because speciation allows for that. But the thing is, humans don't speciate. So if we don't speciate, we can look around at humans today and say, that's the diversity we have with humans. So we can't look around at apes and go, oh, they have a lot of diversity. I wonder if we can be in that diversity. Well, that's what we're looking at. That's what we try to do. And if we can say like, okay, well, prove you can't speciate. Okay, easy, no problem. I can prove it right now. Let's use evolution to prove it. If you go to the island of Australia, there are aboriginals there that had supposedly been there for 30,000 years. If a 25-year generation time, that makes about 1,200 generations. So if anybody were to come along today and breed with a native Australian aboriginal, therefore they would have reproductive isolation for 1,200 generations. That would cause a new species to occur, right? Well, what do we see in animals? Within just 2 generations, we've seen Darwin's finches produce new species. So clearly after 1,200 generations, we'd have a new species of humans, right? Because isolated tribes are everywhere. We've never seen it, ever, not once. So we can tell from the diversity of speciation and the lack of speciation in humans that we do not match anything like that. But a dog and a wolf, completely completely fine because we see the diversity that's built in from them, from the wolf. Now, can you take a Chihuahua and make a wolf? No, you can't, because it's lost genetic information over time. See, we took the wolf, then we created the pit bull, and then from the pit bull, we made the Chihuahua. But we can't go backwards. We can't. It's lost that information over time. So that's what we see. We see loss coming from that bottleneck. Whatever animals, whatever species of animal were on that ark, we see genetic loss over that time from speciation, from a lot of reasons. So that's what we're witnessing. And that's how I would answer, why are we not related to those other things? Easy. Speciation and variation with what we look around. I mean, there's other reasons too, but that's one I would give. How about you?
It's a good response. Yeah, I like to point out, we look back in time to the expansion of genetic information or allelic variability. The evolutionist looks back in time to the contraction of genetic information and allelic variability. They start off billions of years ago with a single-celled like ancestor. And today we have humans, whales, monkeys, so on and so forth, right? So we look back in time at the expansion of genetic information, and therefore the greatest potential for adaptive episodes and new variations to arise, because we hold to created nuclear heterozygosity, that God would have front-loaded the original kinds, including Adam and Eve, with pre-existing beneficial genetic variation that can be called upon through environmental means, natural selection, so on and so forth. So over time, species hit walls, because you have more and more shifts in heterozygosity to homozygosity, more genetic variation to less genetic variation, right? Heterozygosity means a state of genetic diversity. Homozygosity means a state of no genetic diversity. So more and more as these shifts occur, species hit walls, less ability to change. You're not going to take two Chihuahuas and get a wolf, but essentially you can take two wolves, and with that pre-existing genetic diversity, you can get a Chihuahua, but a Chihuahua has hit a wall. Okay. And according to the biblical model, God creates two people that restricts levels of genetic diversity. Today, humans, low genetic diversity, exactly what we'd expect. God creates populations of animals in fully functioning and working ecosystems. And so we would predict and expect mostly higher levels of genetic diversity, okay, in animals. And that's what we find, a greater potential for variation and speciation in animals rather than humans. And that's from the biblical base starting point. And that biblical base starting point leads to what? Accurate retrodictions and predictions. Therefore, it's not post hoc ad hoc. So yeah, good question. Good response, brother. And yeah, I guess we can move on to her next part here. Whoever you want to, I think.
Well, we won't have time to cover the genetic boundaries, but we could touch on Sediba. She said Sediba is the perfect transitional. It has everything you would look for in a transitional species. So let's go over that. Okay, sure. Why would that be the case, though? Is there another explanation? What do we know about Sediba? Well, we know two things. Actually, we know a lot of things, but there's two things that really stand out. They only found two of these things. One of them is beyond recognition. There's not even a head. Mostly, it's just destroyed mixed bones that were found in a cave where a stick of dynamite was put in and exploded to actually inspect the cave, because the cave had sealed itself. So when they went over and they found this pile of disarticulated, broken bones everywhere, they puzzled them together and they created this thing called Sediba. Now, do I think that it's a specimen that if you puzzle together and then you put skin on it, that would actually be the original individual? I actually don't, because it not only is a mix of adolescent and adult species, it's actually mixed with other species as well. Now, Erika doesn't agree to this, but that's beside the point. That doesn't really matter, because we're going to go with what the experts are saying. And no one can seem to agree on this. So when young Earth creationists come along and they try to place these things, I actually think that's probably not the best idea, because we're really only working with perhaps one bone of something else entirely. So it could be wrong. It's wrong classification. So we're going to get into that right now. You take the lead and I'll take over whenever you're done. If you want to, anyway. Okay, I'll go. So basically, what are we going to do with this Sediba? Okay, well, they puzzled it together and they said, ooh, very unique. Look at that. The skull is kind of apish. It has somewhat of an elongated face. It's missing the human-like nose bone ridge. It has a foramen magnum, or a big hole near the bottom, so it looks like it was probably bipedal. It has lumbar lordosis, so it has 5 lumbards in the lower spine, like people have. It has a shorter arm, I think, or it has a longer arm with a human hand. It was a very unique mix of these things. So Erika was right in saying, look at that, look at those features. That's very, very unique, and they are very unique. But as I was saying earlier, one of the things that we should not do, that's a good email, by the way, we're going to show in just a minute, we actually emailed somebody who's a specialist on this, and this was her reply. But what happened is they puzzled this thing together, and it seems as though they took human bones and primate bones and mixed them together. They did the puzzle piece, right? Because the spinal column actually wasn't in the cave. It was blown out, is what they said. They go, look at that, the spine's over here. So they actually grabbed it and they put it together and they go, oh, look, there it is, no problem. Well, there actually is a problem. You can puzzle things together like that. And when they go, oh, no, you can't put things together and have them fit so perfectly together. Well, what are you talking about? There was a baboon spinal column in Lucy for 40 years that didn't belong there. Of course, you can make mistakes. The mistakes happen all the time. And the experts are saying that these are disarticulated, which basically just means broken up into pieces, bones of different species, including hominid and Australopithecines. So we're not putting words in anyone's mouth. So we actually decided to email an expert, and she replied with, Sediba is a fiction. And you can see the email right there. And at the very bottom is the conclusion where she said that is true. So if you want to go ahead and take over, this is definitely more your specialty, but I definitely like the subject now since I've looked into it so much.
Yeah, definitely. I appreciate that. So it's so funny because, again, a lot of these evolutionists and some young earth creationists, unfortunately, that want to hold to Sediba being human. I mean, have a look at that face and skull. I mean, is that a human right there? Just standing back as a layperson as well. That's kind of a bizarre conclusion. But there have been paleoanthropologists. There's been experts in the field, just like with every find that we talk about when you're dealing with low quality, low confidence data where everything is contested. Okay. These arguments we put forth, a lot of them are from the very words of the paleoanthropologists themselves. Human missing link may just be a jumble of species. Ella Bin, she and Yoel Rack still convinced that Sediba is a fiction. Okay, I wanted to point out this part here. In fact, their Australopithecus sediba represents a mixture of 2 hominin taxa, hence transitional. Okay, that's where you're getting the mistake that this is transitional when you're looking at chimeric species. Notice this. According to our results, the specimens represent 2 separate genera, Australopithecus and Homo. These genera are known. This isn't rare. There's significant overlap in coexistence, okay? Australopithecines and Homo are known to have jointly occupied sites, as seen in several early South African caves, okay? So notice this. So one cannot rule out the possibility that Malapa also contains remains of the 2 it cannot be ruled out. Even in the paper that Paleologos put up as a so-called refutation of this, Ella Bin and Yoel Rack haven't analyzed that, but in that paper, I believe it was a Ritzman paper, they pointed out that the chimeric understanding of Sediba cannot be ruled out, cannot be refuted. Okay. And notice this, debate over Sediba. Like I said, there's debate, there's contention. The field is fragmented. Whatever find, okay, these evolutionist apologists are holding up, just know there's somebody in the field who will disagree with them. One of the challenges paleontologists face in dealing with the imperfect fossil record is that of distinguishing variation within a species from variation between species. We've pointed that out. It's low quality, low confidence data. It's genetics that are inherited sperm and egg. And how many genetic lines of evidence have we presented during this 3-hour show so far that confirms separate ancestry and refutes universal common ancestry? We haven't even gotten into the main portion yet. Eventually, she's going to ask, how can we draw a line in ancestry? And we got a whole nother 3-hour presentation for you guys. So we'll probably do that in a week or so. So complicating matters in the case of Australopithecus sediba, MH1 is a juvenile and MH2 is an adult, which means that some of the differences between them, notice this, may simply reflect the incomplete growth and development of MH1. Wait a minute. Ben isn't convinced. Fossils of other Australopithecine children had tall vertebra as well, she says. Oh, sorry, guys. Upper limbs. Okay. This is an argument, Erika. I think this is kind of her main argument now. Like, well, the hand is human, but you're saying the arm is ape, and yet they articulate so well. Okay, let's have a look at this, guys. Sediba, upper limbs. If Sediba is truly the immediate ancestor to upright walking members of our genus Homo, why does it have an upper limb anatomy that indicates it spent most of its life in the trees? This conflicts with De Silva and Berger's claim that Australopithecus sediba was a habitual biped, upright walker. Of course, they get around this by insisting Sediba could do both, preferring to spend most of its time in a terrestrial habitat as a biped, but still retaining substantial climbing and suspensory ability. Notice this. Yet these types of contradictory anatomies, with some bones appearing distinctly ape and others appearing distinctly human, are expected of a chimeric skeleton that combines Homo and Australopithecus bones. However, in the case of Sediba's upper limb, it does not appear to be a chimeric, and there are reasons to question the orangutan interpretation of the upper limb and shoulder girdle, and we'll get into that next. Okay, so yeah, where there is significant articulation, okay, and not disarticulation in fragments, then yeah, we can determine this is either an ape or a human. It's the disarticulated pieces of these so-called specimens in hominids and the fragments where we should question them, and they have been questioned. For example, Yoel Rak and Ella Bin. First, the overall morphology of the intact scapula closely resembles those of modern humans, much more so than those of orangutans or any other living ape. The upper and lower arm bones are also morphologically similar to those of modern humans. Guys, I got the source down here as well, if you want to see all of this for yourself. So what then was the basis for the orangutan-like morphology claimed by Churchill and colleagues? The answer has to do with specific angle measurements of the scapula that are used to infer the orientation of the shoulder joint. Example, glenoid and spinal angle, and the position of the scapula on the thorax. The shoulder joint, glenoid fossa, of apes are positioned higher on the thorax toward the head, cranium, when compared to humans. A more cranially oriented glenoid fossa is conducive for overhead arm postures in climbing and suspensory behavior. On this basis, Churchill al. concluded that the scapula of Sediba is positioned high on the thorax as in apes and is most similar to Pongo. This is important right here. However, a high-placed scapula is not unique to apes, and so should not be used as a diagnostic for arboreal locomotion. Modern humans suffering from pathology have been shown to displace a high-placed scapula. In addition, the dwarfed human from Flores, right, Homo floresiensis, the hobbit, Naledi and erectus remains from Demonesi, all display a high-placed scapula compared to those of modern humans. This feature appears to be associated with individuals with narrow upper rib cages. See, again, low quality, low confidence science, because we've pointed out, and I've got, let me see here. I've got a quote here from someone who's not a young earth creationist that points out that various pathologies, various diseases, and evidence for morphological degeneration can be confused, right, when seen in the fossil record, can be confused as being primitive or basal or transitional when it's actually due to pathology, disease. So there's really no way of knowing. Right here, Oxnard. Okay, so here's the book. Here's the actual quote to track it down. It is remarkable that so many features similar to those normally present in great apes and Australopithecus and Paranthropus and in early Homo, H. erectus, and even to some degree Neanderthalensis, but not in modern Homo sapiens, are generated in humans by growth deficits due to the absence of thyroid hormone. In other words, many of the pathological features of cretinism mimic the primitive characters of evolution, making it easy to mistake pathological features for primitive characters. The differences can be disentangled by understanding the underlying biology of characters. So here's the thing. We're not just saying, well, you know, these certain bones, like let's say Floresiensis or Naledi, you know, these are cretinism. No, we're just pointing out the fact. Okay, it's an observation that pathology, disease, and morphological degeneration can be confused or misinterpreted as being basal or transitional, when in fact that's not the case. That's not the case. And when you have these subpopulations, look at Naledi, look at Floresiensis, look at Neanderthals. Neanderthals would be a combination of adaptation, longevity from their pre-flood and immediate post-flood ancestors, and degeneration. They were the most inbred people group that have ever existed. The runs of homozygosity are massive. They have these rungs of identical letters, very little genetic diversity. All these groups, including Erectus, lived in small people groups. Okay, you can fit all the Erectus fossils in the trunk of your car. Where's the evidence of their millions of years worth of existence? We know they were a sophisticated people group. Where's evidence for their civilization, for their campsites, campfires, things like this? They don't exist. Okay. So the point is the environmental conditions that they lived in. If you understand founder effects, okay, a lot of these anomalous features are due to morphological degeneration because these anomalies become fixed. So it's not like it's just one specific disease, like, oh, this one individual has cretinism and therefore all the individuals do. No, it is generation after generation where these anomalous features become fixed, and you have a population. Okay, let's take Homo floresiensis, for example, where you have small body sizes, small brain volume. Natural selection will reduce brain size. Reductive evolution is well understood because brains are energetically costly. Okay, so when you're in an environment like an island where resources and food is limited, natural selection is going to reduce brain size. After a few generations, guess what? That feature becomes fixed. It's reductive. It becomes fixed in the population. The inbreeding, okay, leads to horrible things. These recessive mutations come to the forefront, phenotype being a reflection of the genotype. Okay, I want to read this part here. More questions arise when we consider the digital reconstruction of the MH2 scapula. Recall that the scapula was found in two separate blocks which fit together cleanly. Yet the scapula still lacked the acromion process. This is important because the acromion process articulates with the clavicle and plays a critical role in the orientation of the shoulder joint and the placement of the scapula on the thorax. To restore this missing portion, the scapula of MH2 was digitally reconstructed using an isolated acromion process, UW88103, of uncertain origin. It was found in an ex situ block separate from the scapula block, and it was from the opposite, the left side of the body. Despite its uncertain association with sediba, the isolated acromion process was mirrored and aligned to the right scapula of MH2 in a digital reconstruction. Churchill AL note, the right scapula lacks the acromion process. Thus, the left side of the acromion process was mirrored and aligned to obtain the best fit with overlapping preserved portions of the lateral spine. This is acceptable so long as the isolated acromion process belongs to the same individual of the same species, which may or may not be true. And that's a good point, considering the fact that we're looking at a mixed bone bed. The bottom line is that the evidence used to support an orangutan-like upper limb in sediba is questionable at best. The overall morphology of the upper limb and shoulder girdle is consistent with those of modern humans. Okay, Erika, so she can stop saying that, well, the hand and the upper limb, they articulate. And yet, Standing For Truth is saying that one belongs to human, one belongs to a non-human ape. It's like, no, if they're articulated, then sure, let's look at it. Let's examine it. Let's look at the relevant papers. Let's look at the literature and let's decide, what are we dealing with? Okay, when it comes to a chimeric species, we need to differentiate between that which is disarticulated and that which is articulated, and that which is articulated through some study and analyses, we can figure out, is this, as the evolutionists would say, a non-human ape or a human ape? Okay. From the creationist position, a human, separate from non-human apes. The overall morphology of the upper limb and shoulder girdle is consistent with those of modern humans. A cranially oriented shoulder joint is not unique to Australopiths. Again, it's up to interpretation, imagination, storytelling, inference. Deal with the direct lines of evidence. Deal with the genetic data. Quit running from it. It's the best way to determine ancestry. Too much storytelling, too much guesswork when it comes to these fragments, when it comes to these bones found in the dirt. No genetics associated with them. Unique to Australopiths and is displayed in H. erectus, Homo erectus, fully human. A sophisticated people group. Naledi and the Flores hobbit. Wow. That actually fits perfectly. Fits like a glove, given our model of post-Babel dispersion, inbreeding, founder effects, genetic degeneration, morphological degeneration. All of which have been suspected by paleo experts to be severely inbred. Sediba's morphologically upper limb, human upper limb, is further supported by the unmistakable modern human anatomy seen in the hand. So if you have a hand and an upper limb that's articulated and it's all human, then you can't really say, well, they're putting forth this idea that, human and a non-human ape, they're running at each other and they hit each other at 100 kilometers an hour and their bones explode and bam. That's not how it works. Okay. Not to mention, I've got quote after quote where these paleoanthropologists admit that Homo and the Australopiths have coexisted, intermingled. Heck, those members of the Homo genera probably ate Australopithecines. Humans have eaten all sorts of things. No wonder we find the bones together. Sediba's morphologically human upper limb is further supported by the unmistakable modern human anatomy seen in the hand. Both the hand and the upper limb bones of MH2 were found in close anatomical association. Because they were found in close anatomical association, we can differentiate between that which is human, that which is, according to the evolutionists, non-human ape. Okay. But when it is disarticulated, when we are dealing with fragments and isolated bones, that is where, and just consider Ella Bin and Yoel Rak, for example, that is where we get the misinterpretation of identifying what it is, human or ape. But what's interesting is, even for sake of argument, if Sediba was a legit taxon, it's a dead end. It's been ousted. Australopithecus sediba, not likely human's ancestor. Temporal evidence shows Australopithecus sediba is unlikely to be the ancestor of Homo. New studies shake up human family tree. Right here, statistical find finds that unlikely South African fossil species is ancestral to humans. And we can go on and on and on. So there's one other thing I wanted to point out here. Matt, we're not going to have any voices for the next little while. Make sure to leave no stone unturned. And the next program we do on this, we're getting really, really in depth into the genetic related data. Okay, right here. Pleistocene hominid discoveries in Hadar, Ethiopia. The collection suggests that Homo and Australopithecus coexisted as early as 3 million years ago. Coexistence of Homo and Australopithecus. The coexistence of Homo and Australopithecus in early South African sites is not unusual. Again, the paper we were discussing from Ella Bin. Groundbreaking find. 3 kinds of early humans unearthed living together in South Africa. And this quote again, remember guys, Few sciences produce such abundant returns from so few fragments of fact as paleontology. Okay. You'll find Gutsick Gibbon arguing for hours against what we have talked about when it comes to chimeric species. Okay. But just know there's a paleoanthropologist out there that disagrees with her because the field is fragmented, it's contested, because it's low quality, low confidence data, low quality science. A fossil, a fragment, okay, is not inherited sperm and egg. Genes, traits, and genetics are inherited sperm and egg. And that is the best way to determine ancestry. Notice this. This is a great observation. Bernard Wood pointed this out in a book that I have on, it's a secular book on human evolution. Many have observed that while there are thousands of fossils of humans and their alleged human ancestors, there are relatively few fossils of non-human primates. The reason is quite simple. When a non-human primate fossil is discovered, it is not recognized as such, but is instead claimed to be an evolutionary ancestor of humans. Because you know what? Everybody wants to find the next big missing link, or the next big hominid find that can, help us understand the evolution story. But when they find, a non-human primate fossil, it's not as exciting. Or they will find a non-human ape fossil, a fossil that's in the line of the chimpanzees or gorillas or orangutan, and they will misinterpret it as being in the line of humans because you know what? That's where fame and fortune is. And there's a lot of competition in the field of paleoanthropology. They will all admit to that. Okay, Lee Berger himself will admit to that. He's even admitted in a lecture that I watched recently that, yeah, most of the finds are very poor, disarticulated finds, fragments, isolated bones, mostly teeth, fragments from the skull. Okay, it's a sad field, and it's not really telling us much. And so, yes, when we do look at every single example that they can point to, you know what we find? We find that there are either fully human, degenerate human, fully ape, or just not really much in the lines of the various non-human apes. And I'm just using evolutionist lingo. It's like nobody remembers the guy who found the 10th Tyrannosaurus Rex fossil. No, they remember the guy who found the first. That's why they'll take any little morphological variation and make a whole new species out of it. That's why you got Australopithecus anamensis, Australopithecus africanus, Australopithecus afarensis, Australopithecus sediba, Australopithecus prometheus. It's like any little variation, they'll make a whole new species out of it. Even though you find, fossils with the same variation as Erectus, Heidelbergensis, Homo sapiens, Ergaster, all in the same, bone pit. But apparently it's all different species. Or maybe it's the same species, right? The Homo genus with variations within that same species. So, man, we said we would leave no stone unturned, Matt. So go ahead, brother.
Yeah, no, you said it right there. They actually, Lee Berger himself even said, yeah, we see like a lot of these primate species being around 3 feet tall, and all of a sudden there's a jump to Homo at 5.5 to 7 feet tall. Imagine that. The first humans he discovered in Africa, in the deepest layers, are 7 feet tall. The video will be on this channel soon as I update it. So that's an interesting one. Another one is a lot of the mindset that goes into paleontology and how we reconstruct something goes to the mindset that we have. So if we go back in time to the ancient Romans, they believed in demigods, and they believed that giants walked the earth. And so they actually, when they were, digging up dirt and building foundations for Rome and roadways, they actually came along elephant bones. They had never seen an elephant. So when they reconstructed it standing up. And in the middle of its head, it looks like there is just one hole, where they thought an eye went. So they actually thought they found Cyclops. And that's where that idea originated from, is they constructed these giant elephant skeletons standing and said, look, Cyclops. And it came down from their interpretation, their idea of what that thing probably was, with their already preconceived notion that demigod giants were walking around on the earth. So when you have the preconceived notion that we have growing up through school that evolution is true and must be true and there's no alternative, when we go into the fossil record and we see these little monkeys and we believe that that chart march of progress is true, the Darwinian idea, then what do we do when we find something that is a little bit larger in the head? Well, there we go. There's the intermediary. We can make that transition. So we can reconstruct anything. So basically, that's what they've done. It's the mindset. It's the conclusion driving the paradigm, which is funny because that's what she blames us for doing. But we actually don't just go, yeah, God definitely did it this way, and we need to prove that that's true. No, actually, we take the scripture and we go, if this is true, let's test this. It's called a hypothesis. That's what we do. Darwin's actually the one that started with his father's idea of evolution being true from deep time and built it off of that. He was the one that started with the conclusion and jumped backwards. So he went around and was like looking at a moth, and he was looking at this flower and said, I predict that there's a moth that could pollinate this. Well, no kidding. That's like saying, I bet you there's a key that goes in this door to open it. Well, no kidding. How else is it going to get pollinated? It's the most ridiculous. The things that he predicted were so ridiculous like that it was obvious that he was going to get some predictions right. But the predictions that were the most important of all are the ones that were the biggest failure. That's why there's so much discrepancy. So we can even talk about some of those right now because there won't be time to break up the ancestry thing. But I think it would be fun to just go through real quick some of my ideas that I think shatter evolution. And it's really just going back to what they've said, because that's the easiest thing to do. Evolution predicted slow, gradual change over time. And they predicted that there wouldn't be genetic similarity between anything because deep time would have eradicated all of it. So if we actually go back to 1975, prior to any genetic analysis, the Institute for Creation researcher, Dr. Henry Morse, asserted that there would be a common underlying design pattern to explain all of the structures that we see. He said the creative process could have designed similar structures for similar functions and different structures for different functions. In the creation model, the same similarities are predicted on the basis of common purpose of a designer. So evolution predicted the exact opposite. In 1963, Harvard's leading evolutionary theorist, Ernest Mayr, predicted that by looking for genetic similarities in DNA between diverse organisms would be pointless. He claimed that random genetic changes over millions of years explained the differences in creatures' traits, and that those many changes would have obliterated genetic similarities. Today, we see their prediction was wrong, and this falsification turned out to be so bad for them that no one even hears about this anymore. And it was the young Earth creationists that predicted it to be absolutely what we see today. And what has evolutionists done? They've actually flipped that now, right? And now they use that as their best evidence for evolution when it was a falsification of their predictions of evolution and deep time. That's why they invented the bottleneck. They had to. They don't see any bottleneck in their fossil record. There's nothing there. They had to invent some global catastrophe happened that they can't find, by the way, 200,000 years ago. Why? Because everything has low genetic diversity. Everything's so commonly related on the genetic basis that they're like, how is this possible? Only could happen if there would be some recent event. So they invented what we already predicted, Noah's global flood, which is right there. So the hypothesis stands true. We found the evidence. Boom. It's now a theory. It's perfect. Unfortunately, guess what? They don't allow catastrophism in school anymore because Lyle came along and said, that's not real science anymore. What's real science is what I made up in my office because I'm a lawyer in New York. Wonderful. That's the type of science we get with evolutionism. Unfalsifiable nonsense that's actually refuted down the line. But I can go on. Unless you wanted to share something.
No, keep going. Keep going, brother.
Sure. Okay. They predicted slow mutation rates. We found fast, the exact opposite. So what they do, they invented the phylogenetic mutation rate to go with the fossil record. Completely contradictory. What do we use in medicine? We use the pedigree rate, the observable one. Why? Because it's true. What do young Earth creationists use? We use the observable one and we make predictions on it. They don't make predictions on it. Wonderful, right? They predicted high genetic diversity. We found low, the exact opposite. They invented the bottleneck to save them. They predicted slow speciation. We found fast, the exact opposite. Boom, again. They predicted a slow fossil record of gradualism. Like I said earlier in the show, boom, they found the exact opposite. We found everything that you shouldn't find. Stasis, punctuated equilibrium, rapid radiation events, everything fast, everything in between. Unfalsifiable yet again. It predicted inbreeding of a small bottleneck of just 2 would cause inbreeding problems to kill everything. Guess what? Founder effect. Everything works just perfect. Shocker, I know. They predicted a high population of women going back 200,000 years ago. We found a single mtDNA line going back just thousands of years ago. They predicted high male genetic diversity going back even longer. Guess what we found? Single maternal line going right back to a single male just about 4,500 years ago. They predicted genetic increase over time. We see genetic decay over time, the exact opposite of the predictions. It predicted harmful mutation rates would have been around for hundreds of thousands of years. Guess what? SNVs and all harmful mutations rose about 5,000 years ago. In their own words, evolution theory assumed beneficial mutations given drive evolution forward. Guess what? There's not even enough time for most of them to occur. All of the timelines that they invented from their fossil record aren't true when it comes to the genetic information and biology that we have. So they invented a fossil record and then said these layers are different ages. And then they go by these radiometric dates, which are very systematic because, they're by weight. So as they go down into time, they go, okay, must have been when this creature evolved because we found it in that layer. Then they test it based on how often beneficial mutations occur, and it's not enough time. That's called a waiting time problem. It's just next after next. They never predicted taxonomic restricted orphan genes, right? Guess what we found? They never predicted functional ERVs. They're considered junk DNA, 100% worthless. Well, that was wrong too. They never predicted groups of organisms having the same features. That's why, like, for example, flight found in birds and insects and reptiles and mammals and even fish and insects, right? Oh, what was it? What did it? Oh, convergent evolution must have done it, I guess. I don't know. Remember when the state, what is that fish that was in complete stasis? The coelacanth, yeah. They said, oh, that went extinct millions of years ago, and it was a bottom dweller. What did they find? They found it wasn't a bottom dweller at all. It swam somewhere in the middle of the ocean, and it was still alive, and it was just like a random new species, right? So it had speciated a few times over the last, thousands of years since the flood. Well, guess what? That thing had to survive over 300, 400 million years? Oh, yeah. No bottlenecks in their theory through that amount of time, right? Craziness. I mean, that's just part of the things that are on my notes, dude. It's insane. Everything that they predicted was literally wrong, which means it's a falsification because it was a prediction that they made. Where have we been wrong? Where are our predictions coming to utter failure after failure after failure? Our model is pretty consistent. We take the Bible and we go, let's test this thing, see if it's true. Let's see, it says that there are people created over here. Okay, well, what does the maternal line show? Well, bam, we take that right back to Eve. We can answer the genetic diversity better than the evolutionist. And that's all that evolution's goal is to explain the genetic diversity that we see on the world today. So it's ironic that we explain it better than they do.
And remember, their best rescue devices, like here's one, coalescence theory. They'll invoke this and say, well, it was expected. One mitochondrial DNA, one Y chromosomal ancestor. Oh, really? So here's a reference here. Mitochondrial leave is absolutely not necessary because, for one, random mating. Is that realistic? Has that existed throughout history? Yeah, people existed in tribes, married within their tribes. Okay, definitely not expected. Absolutely not necessary according to evolutionary theory. There was every possibility that we would have found multiple diverse mitochondrial DNA lineages with modern people, and that some or all of these would be shared with chimpanzees. And yet, remember, the Y chromosome, both uniparentally DNA inherited compartments, both non-recombining DNA compartments. Okay. Not the autosomal DNA, uniparentally inherited DNA. That's not as messy. We can build nice and well-organized phylogenetic trees. And it just turns out that both DNA compartments trace back to one Y chromosomal ancestor being Noah 4,500 years ago and one mitochondrial DNA ancestor. Did not have to be true if evolution were true. but it is true. That's the facts. That's the data. Deal with it. There's every possibility that we would have found multiple diverse mitochondrial lineages. Mitochondrial DNA, nothing like the chimpanzee mitochondrial DNA within modern people, and that some or all of these would be shared with chimpanzees if we really were related to them. This was not found, and so coalescence was brought in to explain the differences. Matt, you went over a ton of rescue devices. It's all about rescue. That's why we put together that book, The Evolutionary Rescue Device, or the Rescue Device Handbook, because there's so many.
So many.
Yeah, that's all they got. This was not found, and so coalescence was brought in. It all depends on historical demographics. True, if you have a small enough population for a long enough time, all mitochondrial lines are expected to converge as lineages are lost due to drift. But we do not know the genetic history of the two species in question. We can only model. And the creation model happens to fit the evidence without any tweaking, just like the Y chromosomal dissimilarity between chimpanzees and humans. We don't have to start invoking all these different fancy stories. Okay, no, we have a model and it fits perfectly. Now, these guys have, XYZ, maybe the Y chromosome is so different because of this, this, and this. Sperm competition, gene conversion, whatever. Okay, give us a model. Give us some testable predictions. Give us some mathematics. No. Okay, without any predictions, without a model, and all you have is a story and imagination, it's not science, it's pseudoscience. We can only model, and the creation model happens to fit the evidence without any tweaking. Coalescence was a post hoc evolutionary explanation brought in after the relevant data were accumulated, just like the post hoc, ad hoc, out of Africa population bottleneck, where it had to be extended. Not one generation followed by rapid and exponential population growth like the biblical bottlenecks. No, it had to be extended. It had to be many, many, many generations in order to adequately reduce levels of heterozygosity and increase levels of homozygosity, in order to explain why humans today have incredibly low genetic variation. Okay, that was an invention after the fact. It is a case of retrofitting the data into your story instead of admitting that maybe my story is wrong. Okay. But the problem is, because you have such a prolonged bottleneck in Africa with a small population, let's say anywhere from 10 to 30,000 people, that means you have generation after generation after generation of inbreeding, and therefore the manifestation of deleterious mutations that are hidden in recessive form. They come to the forefront, and they lead to rapid and accelerated genetic degeneration. But we are supposed to believe that this population of 2 to 10,000, some say 30,000, they don't know. It's all a story. They don't know how long this bottleneck lasted. They don't really have any details because it's just a story that they made up. Okay, but supposedly this highly degenerated population of whatever, 2 to 30,000 people, after a near extinction event, spread out in all parts of the globe, seizing dominion over the planet, eventually building the space shuttle, designing these laptops that we're on. It's a fairy tale. It's story time when it comes to the evolutionists. Okay, this is the raw data. The raw data doesn't lie. This isn't fossil data. This isn't low quality, low confidence. No. What we see in terms of worldwide mitochondrial DNA diversity and worldwide Y chromosomal DNA diversity is one Y chromosomal ancestor, one mitochondrial DNA ancestor. We have an expected pattern. Oh, that's not rooted. That's unrooted. Yeah. And guess what? The unrooted representation gives us the most fluent reading of the data without any evolutionary assumptions. Okay. And now we have Dr. Nathaniel Jeanson, who has confirmed predictions that he's laid out. Notice this, something you won't be seeing Joel Duff address. When I wrote the book, Replacing Darwin, in 2017, this was the standard I sought to meet, the gold standard of science, making testable predictions. Replacing Darwin contains numerous testable predictions. One in particular applied directly to the question of human origins. The young Earth creation anthropology that I just outlined makes another prediction. Since my model traces the origin of nearly all the common DNA variants back to Adam and Eve, my model suggests that the history of civilization can be read off the nuclear DNA differences. That includes the Y chromosome. Among the peoples of the globe and on a time scale consistent with the young Earth creation model. For example, in the last few hundred years, European colonization and the transatlantic slave trade have resulted in major geographic movements of peoples around the globe. These movements will leave a signature in the genetics of each of these peoples. I also articulated these claims with respect to a specific type of nuclear DNA that is inherited only in males, the Y chromosome. Thus, both the mitochondrial DNA and the Y chromosome sequences have the potential to act as a strict absolute molecular clocks. The rate of mutation in each of these compartments will determine how precisely each can measure time. But the fact of a clock is true in both compartments. Therefore, the timing of the origin and migration of various people groups can be interrogated with these genetic tools. The Y chromosome differences among modern humans represent, in theory, the first type of nuclear DNA signature of the history of civilization. Notice this. Okay, what I'm about to read. These evolutionists just pretty much have to ignore it or make sure it goes in one ear and out the other, or just claim that Nathaniel Jeanson's lying, apparently. Since then, I've published 3 papers that directly confirm these predictions for the Y chromosome. Directly confirm these predictions for the Y chromosome. It is the young Earth creation model of ancestry that is meeting the gold standard of science. Okay, there are testable predictions being made, and they are being tested. They are being worked out in active research programs, and they are being confirmed. Predictions that can only be true if the biblical creation model of ancestry were true. Matt, what are your thoughts, brother?
I like it. I just think that what's crazy is they're the ones complaining about our model when they're the ones that are making retrodictions. They're waiting for the evidence to come in and then building the story around it. Like, they would have never predicted the chromosome dissimilarity, right? Between us and primates. Right. They found it. What they do? They say, "Oh man, there must have been a fusion." That's not a prediction. That's a retrodiction. Right. You discovered it and then went, "Oh no, what are we gonna do? There must have been a fusion." So what they do? They made one up. Great. What did we do when we inspected it? Well, guess what? It's not really a good, very fusion event, huh? Left no evidence that it actually was one with satellite DNA, which is there when every other chromosome fusion. Oh no, that evidence just erased itself. Somehow we're magical beings that are so different than every other species on Earth. We can eradicate all versions of satellite DNA that had ever happened. Yeah, keep dreaming, evolutionist. She also says that we start with a conclusion. Okay, you know what conclusion we're starting with? The scripture. You know how bad that is for us? That means that our model is locked in stone, and that if anything that we predicted based off of that model is wrong, we're finished. That's the worst kind of model you could have. We can't wing it like you guys. You guys don't have one because you can change it tomorrow. It doesn't matter. You guys have changed. Every missing link that you guys have invented has been wrong, and it doesn't matter because you can just say, "We learned more." Oh, it doesn't matter. Okay. You see what I mean? Nonsense. They're complaining because that's all they can do. That's it.
That's all they can do. I mean, they can't match up to the predictions being made here. Okay. That's why they have to so heavily focus on these bones found in the dirt. The data that even their own side admits can sing any story you want it to.
Yep.
And that's where we're going to look to answer this question of ancestry. The last thing I want to address here, leave no stone unturned, is this one specific pseudogene, gulo pseudogene. And then we're going to save, I believe, Matt, the next part, which is going to have to do with genetic boundaries and where we can draw a line. So the next portion, Erika is going to mention that. You know, she's going to say, even though we've provided numerous irrefutable lines of evidence as to where we can draw the line on ancestry to demonstrate separate and not universal ancestry, but she makes the claim again. Nobody's answered my question on that. Well, we're going to do an entire program on that because we're coming up on 4 hours just for the first half of her show. Or maybe we got through a little more than half. I'm not sure. So here is the Gulo pseudogene argument she likes to put forth. Okay. So let's go through this. This is a really, really technical paper that I highly recommend everybody read through. Okay. By Dr. Jeffrey Tompkins. Here's a few excerpts. Okay. And we also know, Matt, wasn't there a paper that came out recently that talked about how, you know, mutations are not as random as evolutionists once predicted or thought? I mean, there's a lot of mutational hotspots in the genomes of living organisms, right? A lot of spots in the genome that are more prone to degradation and gene loss and mutational breakdown. Isn't that right?
Yeah, absolutely. I guess it would be like your car. What would wear out first, your door or your tires, right? I guess there's just certain regions of the body that are designed to withstand and tolerate mutations. And we can look inside the mitochondria, for example, and we can go right to the D loop or the control region. And there's the hypervariable region 1, which actually is a hotspot. And then there's hypervariable region 2, which mutates half as fast as that one almost. Not quite, but you know what I mean? We're seeing areas where mutations accumulate and where they turn over. So absolutely right.
That's a good point. That's a good point. And when it comes to specifically vitamin C synthesis, we as humans, and you're the expert here when it comes to nutrition and diet, we eat a lot of fruits, vegetables, foods, and take supplements that have what? Vitamin C. I mean, how necessary is it for humans, according to the biblical model of ancestry, to synthesize our own vitamin C? How detrimental is that?
Well, we're told specifically from the beginning that God gave us the fruit of all the trees to eat. So it was to be for us as food. So therefore, it would be absolutely required. And we see that when we look at sailors, they get scurvy when they don't consume any vitamin C for any amount of time. So we still are bound to what we were created to eat, which was the fruit.
So if throughout history, biblical history, let's say, humans are eating a lot of fruit, consuming a lot of vitamin C through foods, now supplementation, wouldn't that be a gene that's more prone to breakdown then?
Absolutely, because if you look at a lot of the supplements themselves, they're not what we find in nature, meaning they're what's called ascorbic acid or ascorbyl palmitate. And these are single elements that mimic the chemical of vitamin C. They're not the actual vitamin C that we find in nature, which is a thin ring of ascorbic acid wrapped around a copper molecule that has the other vitamins around that you actually get to help assimilation and the bioflavonoids that you get for absorption of the vitamin C. So yeah, it's completely different. And now we're in a time where people eat McDonald's for almost every meal, and then they try to supplement a multivitamin, and it's not as good. So we're messing ourselves up pretty bad. Yeah.
So if humans started off with a functional and working vitamin C synthesis gene after the fall due to environment, would that not be a gene that's going to be more susceptible to genetic breakdown?
Oh, absolutely. Anything, it's like a cascade, like a domino effect. Usually when there's one problem, it gets worse and worse and worse. You know, that's it's kind of how it goes. Mutation accumulation, right? We're seeing the buildup of mutation, which is a good thing because it shows that everything is young. And it also shows that we haven't reached mutation saturation. Nothing on life has. So that was another prediction that Dr. Jensen had, is that if life is really young, then when we look in the mitochondria, which can't get rid of mutations really, then there would be an increase of genetic diversity. So when we look around, what do we see? Genetic diversity is still increasing, right? So clearly we haven't reached equilibrium where life has lived long enough to reach mutational saturation. And when we look in the mitochondria, which is 16,569 base pairs, what would we expect to see with mutational saturation? Well, that number's around 12,000. Once it reaches that, which is like 3/4 of the way up, mutations just start to flip over. But what do we see when we look in there? There's only like 1,000 or so. Why is there so few and such a fast mutation rate? It's because life is young, people.
Right.
That's it.
It's the only way to explain it.
That's it.
It's the only way. So it would be like somebody like you who consumes an antioxidant rich diet, right? your body, one could say, is more alkaline than acidic. If you were to suddenly do what that guy did in the documentary Super Size Me, where he ate McDonald's breakfast, lunch, and dinner for months, with somebody like you, with your diet, you'd probably go downhill real quick. Your body's not used to that. And therefore, it's going to hit you harder than somebody who already eats fast food day in and day out. Is that right?
Yeah, it also has to do with weight. I don't have much body fat because I like to train a lot, and I also do fasting. So not having much body fat means there's no buffer, because fat is where we store our toxins, and toxins dump into the bloodstream. So if I don't have much fat and you eat bad things, it's definitely going to go right into your system, and you're going to react even worse. So, if I get bad sleep, if I train too much and I don't eat, I get affected much, much more. So yeah, bad foods would definitely wreck me much quicker. And they usually do, actually.
And believe it or not, here where I live, we have some pretty bad winters. Cars of all kinds. Okay, surprise, surprise. Cars of all kinds, different manufacturers, SUVs, vans, sedans, whatever. They all in the wintertime here have problems starting. We constantly got to jump start them, okay? And certain cars, like if my, let's say, Chrysler 200 I used to have, or somebody else, their Chevy Cruze, my buddy's Chevy Cruze, if the air conditioner broke down in the exact same way, in the same spot, being the air conditioner, that doesn't really prove anything that those two vehicles now share a common sedan ancestor in the Arctic. Okay. Certain things are more prone to breakdown. Okay. So I want to point this out, and I think the audience now knows where we're going with this. Okay. Degradation. We're not just making this stuff up. This is just well known. Degradation of the gulo gene in a wide array of mammals and birds is a relatively what? Common occurrence. Loss of vitamin C pathway function in gulo gene degradation has also been detected in guinea pigs, great apes, and humans. In addition, naturally occurring scurvy and osteogenic disease pathologies related to gulo inactivating mutations and large-scale deletions have been documented in rats, mice, and pigs. One of the key arguments, which Erika used by some proponents of evolutionary dogma, is that the human and chimpanzee gulo pseudogenes are examples of inherited shared genetic mistakes. However, as demonstrated in this report, overall evidence for common ancestry across the entire human gulo locus with chimps and other great apes is completely negated by the following discovery. So here's a few reasons, guys. When they say, you know what, we share this genetic mistake, this gulo pseudogene in the primates, and it's broken in the exact same way. That's a lie. That's not true. It's not broken in the exact same way. There are some vast differences in how it's broken down. And correct me if I'm wrong, Matt. We've been going for 4 hours, so my mind's all over the place. She didn't go into detail on this yet. She goes into detail later, right? Or I know she mentioned like genetic mistakes earlier, but did she specifically mention this one now or later? I know I can't remember either. It's been 4 hours, but that's fine.
I don't think. Yeah, if she did, she just skimmed by it. It must have been really quick.
I'm pretty sure she uses it later, which means
that's good.
For our next show, we'll just refer people to this section and just follow specifically on boundaries next show. Compared to chimpanzee and gorilla, the 28,800 base gulo region in humans is only 84% and 87% identical to chimpanzee and gorilla, respectively. The 13,000 bases upstream of the human gulo region corresponding to the putative area of loss for at least two major exons is only 68% and 73% identical to chimpanzee and gorilla, respectively. The individual 6 exon regions, which are generally very similar among humans and various apes, each, notice this, independently. Okay, guys, so what we see is taxonomically independent breakages, independent from, let's say, humans and chimpanzees being related and therefore inheriting the mistake from a common ancestor in the past. Each independently exhibit completely different and discordant phylogenetic patterns of similarity for all but one exon. A general lack of human SNPs, single nucleotide polymorphisms, in these exons indicates that incomplete lineage sorting based on alleged ancestral polymorphisms is not a likely explanation. This one's important. The transposable element content for each region of putative exon loss is taxonomically restricted and evolutionarily discordant between humans and each ape taxon. Unequal recombination associated with transposable element repeats can lead to disruptive deletion events in the genome and likely did in these regions. Okay, so notice this. In the case of vitamin pathway genes across the spectrum of life, this is what we were talking about earlier, me and Matt, there are widespread documented instances where these seemingly unitary sequences have been broken and the lost vitamin is supplemented externally through diet or a host relationship. Another important aspect of consideration for the gulo gene degradation found in humans is the fact that it occurs frequently in mammals and birds. And the events typically are associated with complete or partial loss of exons. This indicates that the gene, remember we were talking about earlier, mutational hotspots, may be predisposed to the effects of genetic entropy. What's funny is evolutionists will oftentimes look to mutational hotspots when they find contradictory lines of evidence. But yet when it comes to this, they want to just ignore the reality of genes that are more predisposed to either mutate or just degenerate in general. Sometimes greatly, just destroy the whole gene. Thus, contrary to popular opinion promoted by a variety of evolutionary propagandists, Erika being one of them, gulo gene dysfunction appears to be a widespread feature. You don't oftentimes hear that, when they're using this argument, among not just humans, apes, and guinea pigs, but terrestrial animal life in general. But most importantly, patterns of gulo DNA sequence degradation are taxonomically restricted and do not support the macroevolutionary model of origin. So the next time that these evolutionists point to this line of evidence, you point out how easily it is refuted. These exon deletion events are taxonomically restricted in humans and in each of the different ape species tested, and in combination with an extreme lack of sequence similarity over the entire gulo locus, utterly negate the idea of macro evolutionary common ancestry. Matt, let me just see what we're in store for next time.
All right.
We've really dismantled this first. Let's see where we're at. 16 minutes roughly. That's pretty good. Let's see what her next couple minutes are. I wonder if she mentions the gulo here.
Yeah, hit play.
Let me mute because there's an
in there. It kills me that Allosaurus's ghost is probably like just writhing in agony of where it's being placed. It's like all the places really here. So yeah, it's a lot.
Did you do anything on it on your channel, or have you profiled?
I do. It's actually my best performing video. It's got 150,000 views right now. It's my documentary, my opus, right? My summer project. And I went through the Creation Museum and I took as many pictures and as much video as I could. And I did a long, detailed, well-sourced takedown of the science behind it, or lack thereof. Greatest hits are pretending that the speed of light can be changed to that the speed of light is variable to the degree that you can cram 13 billion years of the universe's history to 6,000 years. That's excellent. That radiometric dating doesn't work. Of course, I guess they're unaware that the entire energy industry relies on radiometric dating working to fuel our economy globally. Water in order to figure out where to drill for oil. That's done with radiometric dating.
Isn't that argument based on the fact they're using the wrong methods to date? Oh, dinosaurs and carbon-14. You don't use carbon-14 on, right?
Yeah, you can't carbon-14 date anything that is older than the range changes as our technology gets better, right? Because you can actually detect more minute amounts of carbon. But the general range tends to be 50,000 to 80,000 years, and 80,000 is really pushing it. Like if you get a 50,000 year date, it's almost definitely contamination, right? Because there's carbon in the atmosphere, and it can contaminate a lot of this material and give you these.
All right. We'll deal with those parts at the beginning of our next show. So we'll deal with really quickly distant starlight, radiometric dating, since we're going on 4 hours. My voice is almost completely gone. And then and then we'll get into the boundaries and all of that. What's funny about the fossil fuel industry, we've already done a series with Professor David McQueen, just destroying that argument, and also put forth a challenge to Mr. Wilford or whoever. Debate Professor McQueen on it then, and he's run, understandably, and his responses have been really weak. So that we've already dealt with, and yeah, we'll deal with her radiometric dating, distant starlight, and then I think her last several minutes has to do with the boundaries and where we can draw the line in ancestry. So as we just hit the 4 hour mark, Matt, over to you. Any last points you want to make? Any, anything you want to make sure you get out there in order to leave no stone unturned for episode 1 of this 2 or 3 part series. We'll see.
Oh my. Yeah, no, not yet. Like you said, that I'll just go on another tangent or something. We covered pretty good amount over this amount of time.
Go
But
on a tangent. You're allowed, brother.
there's still so much to cover. There's still so much. Every single thing, every word is just crazy. But yeah, it's I like when she goes on these shows because she doesn't think we'll ever watch it, right? She doesn't think a young Earth creationist will be in the audience or listen or review it at all. So she can just repeat the same thing over and over, that no matter how much it's been refuted, right? She actually thinks that young Earth creation can be taken down because of a single model that has a heat problem. Think about that kind of logic, right? So you know, we're dealing with somebody that hates the idea that there's a theory that refutes evolution, and she is all about trying to take it out. Kind of funny. That shows how anti-science she actually is. But we've known that for a while now because we've had 3 debates against her, and she was so embarrassed she didn't even put them on her channel. So what does that tell you?
Well, did you want to exactly check the description box of this guy? I think it's got a few thousand views. It's 6 hours of Team Standing for Truth debating her and not being able to answer these challenges. And she still hasn't been able to, even on her own, in her own video. She dodges. Based on her misunderstandings and misuse of carbon dating there in that last couple minutes, Matt, did you want to read out this slide, brother, and point out its significance?
Oh, I can't see that. I'm on a little tiny.
I guess I'll read it out with whatever last bit we have. Notice this. Most people are confused. That's the first thing I thought hearing Erika here talk about carbon-14. About carbon-14 dating. It is often thought that carbon-14 shows how very old things are. Actually, carbon-14 usually shows us how young things are. Carbon-14 mostly arises in the upper atmosphere. Right, cosmic ray bombardment in the upper atmosphere, where cosmic rays turn nitrogen into carbon-14. The resulting carbon-14 immediately begins to revert back to nitrogen. Some of this carbon-14 enters into living plants and animals. Because carbon-14 no longer enters living things after they die, the carbon-14 clock starts ticking at death. The carbon-14 in a biological sample disappears at a very steady rate, and its half-life being just 5,700 years. This means that no detectable carbon-14 should remain in any biological remains after about 100,000 years. It is remarkable. Notice this, but essentially everything in the fossil record, it's not just this rarity, everything in the fossil record. And we actually put out a video, Matt, destroying their very best arguments when it comes to contamination or the, replenishing of C14 from nearby materials and things like that, nuclear material. And we put out a whole video destroying it. So, we can link that for people who want like a full, any possible arguments that Erika could use kind of thing. We've dealt with them. Everything in the fossil record contains measurable levels of carbon-14. This seems contrary to popular wisdom, but it is widely recognized within the carbon-14 community. Taken at face value, this suggests that the entire fossil record is less than 100,000 years old. Guess what? 100,000 years is not enough to take your fish to fishermen. Many will be offended by this idea. I can already imagine Gutsick Gibbon, being sick to her gut, I guess, as her name says. But like it or not, this is what the carbon-14 dating appears to be showing. When bones of the Homo genus have been carbon-14 dated, give a little space there, they have consistently yielded young dates ranging from thousands to 10,000 to tens of thousands of years. I mean, you should see the contention when it comes to the dates derived from a lot of these hominids. Matt, how about this? The significance of this. Notice this chart. Young rocks from recent eruptions yield greatly exaggerated apparent ages. The data used in this table was retrieved from mainstream scientific journals. Creationists aren't making this up. Why is this significant? Well, Matt, how come this tells us that we probably shouldn't be trusting dates derived from rocks of unknown age?
Yeah, if they can't get the ages right for rocks that are of known ages, makes no sense that we would infer that it would work with rocks that are true. But to me, it wouldn't really matter what any of the ages say, because you know my opinion on it.
Right. And what is your opinion? I think it's an irrefutable opinion, so you feel free to make it.
I like that they've discovered that when super heavy elements decay into the radioactive elements that we now have on Earth today, that they form in the proportions that we actually see on Earth, and that they always date old, even though they were just made the day before. So if we look over and we assume that all of the, say, potassium or all of the iron that's on Earth had to come all the way from uranium and decay through all those things up until we have all the lead, then that assumption is now gone. There doesn't need to be a decay into those other radioactive elements because they're all formed together perfectly in the arrangement that we see on Earth today. So when we look and we see these different radioactive elements on the rock layers and they give those dates, that's what we should expect to see because they are bound by their weight on how much they're going to sink and float, right? The heavier elements are going to sink deeper, and they just happen to date the oldest. So it's not a surprise to me. And if they were literally even created a week ago, it wouldn't matter because they would still date millions of or billions of years old, depending on what you test. So their placement is what we should see, and their dates don't matter at all.
Right. Well, why do we get so many discordant dates then? And how come, some between millions to billions of years? That's because it's not reliable. That's because young Earth creation best explains it. That's the point. You can't trust the dates. You get discordant dates even in isochron dating, which is praised as this, perfect way of dating. So that's good. Over 4 hours, and we've kept between 70 and 100 people the entire time, guys. So I hope you found this great and educational. I appreciate that. Missing Bod says, thanks guys for all you guys do. I love SFT. Appreciate it. We love you too. Share this around. Faithful, honest, and true. Wow, 4 hours and 5, man. Yeah, and then we got a big debate tomorrow too. So we're gonna call it here, Matt. As we say, more things wrong said in one sentence than words in that sentence. So we're gonna take the rest of the night off from talking, heal our voices. We got a lot going on this week. Tons of information. And we'll make sure your screen share works next time, Matt. And till we meet again. Standing for Truth is out. God bless all.